Hey folks, welcome to the use case of Naukri.com. Again, this is the site, this is that platform, which is exactly a recruitment platform. Again, lots of corporates, lots of job seekers believe in this platform. There are the millions of the jobs available on this platform with respect to IT, with respect to management, with respect to law, and there are tons of jobs available on this platform. So first and foremost, we have some raw data. Again, in the real world, whatever data that is given to us, that we have to extract, either this data can be in some databases or this data can be in some big data sources. We have lots of sources just to extract this raw data. Again, in this use case, we have this data in the CSV format. But in the real world, it is not necessary that you will always have a data in the form of CSV format, because it can be in the JSON format, it can be in some big data sources, it can be in some databases, it can be in some relational databases, whatever it will be. So the data that we have is exactly my raw data. So first and foremost, we have to clean this data. Again, the raw data have the lots of typos, lots of error. So first and foremost, we have to clean it, or we have to pre-process it. So once I will pre-process this data, then we have to featureize this data, or we have to perform feature engineering on top of the data that we have. So once we will featureize the data, then I can obtain some set of features that can helpful for us while performing some in-depth analysis. Let's say in this Naukri.com data, let's say we have some, let's say, date feature, or let's say we have some, let's say, feature as, let's say, experience. So considering this date, we can extract some features, or we can extract some derived attributes as, hey, can you return what is a year, or can you return what is a month, or what is a day, or what is a week. So these are typically my featureized data that we have featured itself from this date feature. Similarly, from this experience, hey, can you tell me what is a minimum experience, or hey, can you extract what is a maximum experience. So these are the set of features, or these are my featureized features that I have extracted from this experience feature. So once I have set of features, then I can understand our data much more. So once we will featureize the data, then we will try to understand this data, and we will perform lots of analysis considering this entire data. And at the end, we have to come up with, or you have to end up having some meaningful insights. Again, this is your primarily goal. Again, in this entire use case, we will primarily focus on the problem solving skill, because this is one of the premium skill in the real world. So we will primarily touch upon all the scenarios where problem solving is a key skill. Apart from that, we will also touch upon logical thinking, because logical thinking makes a lot of sense in entire analytics industry. So apart from problem solving, we will also touch upon the logical thinking, and we will also touch upon some of the advanced problem statement, so that we can solve the similar problem statement using some alternatives. Again, just to solve a similar problem statement from lots of ways, it will not only improve your programming, it will also improve your logical thinking. So the key idea behind all this stuff is we will primarily focus on the problem solving and of course our logical thinking, because in the real world, these are some of the premium skills that you have to take care. Again, if you are targeting some of the top product based companies, whether it will be Amazon, whether it will be Google, whatever it will be, whether it will be Facebook, Netflix, let's say Apple, whatever it will be, these are some of the key areas where you have to focus more. Hence, we will primarily touch upon all these areas. So first and foremost, we will try to import the data. Then we will try to do basic data cleaning. First and foremost, we will try to understand all the missing values, doing some basic visualization. Then we will try to clean the data. Along with cleaning, we will try to featureize it. That's what we will do in this entire use case. This is typically my life cycle of this entire project. Once we will featureize it, then we will try to have some set of features, and then only we can perform some data visualization. This is typically my entire life cycle of this entire use case. So I'm going to say, first and foremost, I have to import my NumPy. Then I'm going to say, then I have to import another module, which is my pandas. then I'm going to say I have to import one more module which is exactly C1. So I will say it is exactly C1. Then I'm going to say I have to import one more module which is exactly matplotlib. From matplotlib, I have to go inside this Python plot. Then I am going to say let's create its alias, let's say PLT. Let me just execute this line of code. Now what I will do is, so I'm going to say I have to very first read my data. So I will say pd.read_csv, as it is a CSV file. So I have to call a CSV function, read_csv function. First and foremost, if I will press Shift plus Tab, you can check out the entire documentation of this function. You can check first and foremost, we have to pass some file path where my data is available. So what I will do is, my file path is all about this. Over there, we have my data. So my data is all about, let's say, Naukri underscore job underscore sample. Let me say it is exactly sample and it is exactly CSV. And let me just append the raw string that helps Python just to read the file more efficiently. So what I will do is, I will store it in, let's say, some data frame object, let's say in df. Let me just execute this line of code. And if I'm going to say df.head, now if I will pass, let's say 5, and let me just execute this line of code. These are typically my first 4 rows. Over here, these are my all the columns. And if I will say, let's say df.columns, just to get all the list of the columns in the form of list or array data structure. So if I will say df.shape, these are typically the total number of the observations, and these are my all the columns, 14 columns having 22k data points that we have. Now the first assignment is all about, hey, can you visualize your missing values? So what I will do is, I will say it's all about df.isNull. This is the inbuilt function inside my data frame. So I will say on top of this, just call the sum, just to get a summation of the missing values of all the features that you have. If I will execute this line of code, these are all the missing values that I have. So let me just store it somewhere else. So I will say count underscore missing, and let me just print this, let's say count underscore missing as well. So I will say, let me just print it. These are all the missing values that we have. Let's try to convert all these stats in some, let's say percentage. So what I will do is, I will say count underscore missing. I will say it is exactly count underscore missing. I have to multiply it by 100. First and foremost, I have to multiply it by 100. Then I will say just divide by to the total length of the data frame that you have. Let me just execute this line of code. These are all the values that we are getting. Let me just store it somewhere else. I will say percent underscore missing, and I will just visualize my percent underscore missing as well. Let me just execute. These are all the data in the form of percentage. It says, hey, you have the most number of the missing values inside my number of positions feature. Approx 80% of your data is missing. So again, this is typically my understanding the internals of the data. So now what I can do is, I can merge both the data frame, which is exactly percent underscore missing, and count underscore missing. Again, just to make things more user friendly, you can just merge it. So what I will do is, I can create some blank data frame. Let's say it's missing value, or let's say it's missing value underscore df. Over there, either you can concatenate it, or either you can define some blank data frame and you can just add all the features, which is exactly my percent underscore missing and count underscore missing. Again, percent underscore missing is typically my series data structure. In a similar way, my count underscore missing is also my series data structure, and data frame is all about the collection of multiple series. So the collection of multiple series will give me my data frame. So I'm going to say pd.dataframe. Over there, what we have to do is, let me show you that. First and foremost, we have to pass some data. Let me show you its entire documentation. So inside data, I can think of passing my series, I can think of passing my arrays, or if my data is a dictionary, my column order follows the insertion order. It means inside this data frame function, which is exactly inside my pandas module, I have to pass my data in the form of key value pairs. Again, data frame is all about the extension of my dictionary. It is all about the extension of dictionary. It means Again, dictionary is all about we have data in the form of key value pair. Hence, data frame is all about my key is exactly feature and my value is all about the total observations that we have with respect to that feature. So what I will do is I will say inside this data frame function, my key is all about the feature name that I have to assign to this data frame. Let's say some X, and I can store, let's say, value of all the values of count underscore missing. Similarly, let's say my feature name is Y. I can store all the values of, let's say, percent underscore missing. That's it. Again, if you can pass the data in the form of dictionary, and if you will pass this dictionary to my data frame, I can end up having my final data frame. And this is typically my final data frame. That's it. So I will say over here, let's say my feature name is, let's say, count underscore missing, and I have all the values that are exactly in count underscore missing. Similarly, I have, let's say, feature is percent underscore missing. So what I will do is I will say this time it is all about, let's say, my feature name is, let's say, percent underscore missing, and let's say my values, all the values that we have is exactly percent underscore missing. Let me just execute this line of code. This is typically my data frame that we are getting. Let me just store it somewhere as, let's say, missing underscore value underscore df. Let me just execute this line of code, and if I'm going to say missing underscore value underscore df, let me just execute. This is typically my data frame. So I have most number of the missing values is exactly in my number of the position that we have. Again, just to make things more user friendly, you can do some styling on top of this data frame. So I will say dot style dot background. You can just press tab, and let me say this is exactly my background underscore graded. Yeah, over here if I will press shift plus tab, I can play with some of the color map parameter. Again, by default this is my default color map. So what I will do is, let me show you that. If I will execute this line of code, this is typically my styling. You will see the two lined in a horizontal way gets highlighted. Again, the site name and the number of the positions have the maximum number of the missing values along with the most percentage. That's why it gets highlighted. So our second problem statement is all about, hey, can you understand your features more? It means, hey, can you create such data frame? Let's say I have some features. Let's say in such data frame, let's say I have one of the column as, let's say, features. Second column is, let's say, total unique values, and then let's say the third column is, let's say, total unique categories. Let's say total unique categories. Let's say one of the feature is, let's say, skill. Let's say the another feature, let's say, as company, and let's say one of the another feature, let's say, as industry. So what I need is, let's say, the total number of the skill, the total number of the unique skill that we have. Of course, imagine, let's say, 400, and the total unique skill, let's say, hey, let's say we have machine learning skill, we have deep learning skill, we have computer vision, we have, let's say data analysis, let's say natural language processing. Let's say these are some of the skills. Similarly, with respect to companies, we have some more entries. Similarly, with respect to industry, we have some more entries. So again, the core idea is we have to come up with such data frame just to understand our features more, so that we can represent such stats to our stakeholders, so that they can find some meaningful insight from this stats we have. Again, just to come up with some data frame, we have lots of ways. The first way is you can think of using some for block or for loop. Just iterate using for loop on the list. Inside this list, you can store all the columns that you have. That's it. Again, if you can use the way, you can easily come up with some data frame. Again, but in the real world, always think in an optimal way. Again, if you really want to build an optimal solution, you can think of using some list comprehension code. Again, in the upcoming session, we will try to touch upon all the ways how to come up with such a data frame. We will also touch upon how to build it using for block. Then later on, we will touch upon how to do it, of course, using list comprehension as well. That's what we will typically do in the upcoming session. So that's all about this session. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session, what we have done is we have basically loaded our data, and in the previous session, we have basically this problem statement that we have to solve. So over here, what we really need to do is, anyhow, we have to create such a data frame that looks something like this, that has a feature, let's say all the set of features that you have in your data frame, and with respect to each and every feature, you have total unique features, and in one more feature, you have total set of all the unique values inside that skill feature. Of course, there are two ways to do this. The very first one is, you can think of using this for loop and just use some basic iteration, and you will end up having your data in some data structure, and then you can finally create your data frame. That's what my first approach says. The second one is, you can think of using my list comprehension, and using list comprehension, of course, this is one of the optimal way to do this similar task. So let's try to do it using both the approaches. So very first, let's say I'm going to say, hey, can return me what are the total unique values in each and every feature. So I will say for column in df.columns, because df.columns will give us a set of all the columns in my df data frame. Let me show you that. If I will say, let's say if I will say df.columns, and if I will execute this line of code, you will see these are all the set of columns that you have. Now what I will do is, I will just iterate on top of this list whatever I have. Then with respect to each and every column, I will say df of column dot any unique. It will return me total number of unique subcategories inside each and every column. So it will exactly return me that stats. Now what I will do is, I will say, hey, can you make this stats more user friendly? So I can use my print statement, and inside this print statement, I will say, I will add my placeholder, and I will receive the value of this placeholder, of course, from my format function. I will say this feature has, let's say that much missing values, or that not missing values, that much values dot format. I will receive its value from my format function. The very first placeholder gets replaced by my column. The second placeholder gets replaced by this placeholder. Now what I will do is, I will say I have to add two more closing braces. So let me just execute this line of code. Now you will see company has total that much unique values, education has that much unique values, and all other features has that much unique values. Now what you can do is, of course, I can define some list, and I will say, once I will define that list, then I will say, hey, let's say with respect to each and every column, can you insert the total number of the unique values along with the total unique subcategories with respect to each and every feature, with respect to company, education, experience, industry, and all these features. So of course, I can use some basic for loop, just define some blank list, just iterate like this, and just insert some values using append function. That's what I will do. The second approach is, I can use some list comprehension code. I will just come up in a while and explain all these things. What is a list comprehension? So I'm basically going to say for column in df dot columns, of course, with respect to each and every column, what I will do is, I will say very first, let me define some blank list. So I will say, let's say its name is, let's say, unique. Whatever list you have defined, I will say inside this unique list, I will just call an inbuilt function, which is a append. Now what I will do is, I will say df of column, of course, dot n unique. It will insert all the unique, or you can say total number of unique values inside this unique list, along with the total set of features or unique subcategories available in each and every column. So what I will do is, I will again just copy this line of code and again paste it, and again this time it is nothing but unique. And if I will execute this line of code, but before executing that, you have to say, I have to insert it in the format of course, list. So if I will execute this line of code, now all steps gets executed, and if I'm going to say, hey, can you print your unique? Now you will see in each and every feature, of course, this feature is exactly my company. Or if you want to insert this feature, what you can do is, you can insert this feature as well. And if again I will execute, and if again I will execute, now you will see with respect to this company feature, I have that much total unique values, and these are all the set of unique values that I have inside this company feature. That's what my unique list will store. Again, there is one more way to perform this similar task what I have done over here. So what I can do is I can say I have basically this for loop. So I will say very first I have this for loop. Now once I have this for loop, what I have done is I have say whatever you have, just perform this operation with respect to each and every list. Then I will say just perform this operation with respect to each and every column. So if I will execute it, but before executing you have to make sure that this is exactly my list. So I will say very first this entire stuff is also my list or an array. So I will say this entire stuff is also my list. So if I will execute this line of code, now you will see you will get similar stats what you have achieved by writing 3 lines of code. But over here you don't have to write 3 lines of code, and of course it is much more user friendly and it is much more efficient because this is the code of the list comprehension. So what it internally does is, so very first we have this for block. Of course we have this for block, then whatever we have to append in the list, this is that entire stuff that we have to append in this unique list. So what I will do is I will say whatever operation you have to perform, you can just like this. So that's like, hey, let's say whatever I have for, let's say I have a string, let's say I have a string as, let's say Shan, let's say I have a string, let's say Shan, and I have to convert it into list. So I will say S, H, A and L. Let's say this is that list in which I can convert that. So what I will do is I will say for X in this Shan, whatever name you want to mention, I will just append each and every X, whatever list I will define, let's say list 1. So I will just append each and every X in this list 1. That's a very basic code what we often write. But if we have a code of list comprehension, then I will say for X in Shan, then whatever X I have to store this in my list. So I will say just store them in my list. That's a very layman explanation of whatever list comprehension code we have. So this is my for block, whatever condition we have, and this is the operation that you have to perform, or you can say this is the operation, or this is your condition. This is the condition, and this is entirely your list comprehension that we extensively used in context of real world. Now I will say, let's say this is my unique df. So I'm going to say this is exactly my unique underscore df. So let me just execute this line of code. Now what I will do is I will say, let me just cancel out this cell. Now I'm going to say I have to create a data frame. So I'm going to say pd.dataframe. I have to just pass this unique underscore df list, whatever I have mentioned. Then I have to assign some column name. So I will say exactly columns is equal to, the very first is exactly my feature name, or I will say my column name. So I will say this is my column name. The second one is exactly my count, of course. The third one is exactly my unique categories, or you can often term it as unique. Now this is, if I will execute, let's say, so this is that column that we all are waiting for. This is the company name, this is the feature name, of course. These are all the total set of unique values, and these are the set of values with respect to this feature. This is what we all are thinking for. Now I'm going to say, let me name this data frame something else. So I will say, this is count df. So I'm going to say this is exactly my count df. Or if you want to customize this data frame, what you can do is you can provide some kind of styling. So initially what we have done is we have just provided this kind of styling to get some raw idea, or to get some better idea what exactly inside my data frame, what exactly is going inside my data frame. So if I will execute this line of code, now you will see over here, these are all my data frame, and we have all this set of features. This is my column name, this is my count, and this is of course my unique feature, and these are all the unique values in my experience. In case of skills, let me show you that in case of skills, what are all the total set of skills. Let's say, hey, marketing. IT software, application programming, accounts, production, sales, IT software. So these are all the total set of unique skills that we have inside this entire data frame. So that's all about this session. In the upcoming session, what we are going to do is we are just going to perform data cleaning and of course featureization on top of my parrot feature, which is exactly, let me show you where exactly we have that feature is. Yeah, this parrot, which is exactly one of the most complicated tasks in the entire life cycle of data science project. So first and foremost, we will clean this feature. Once we will clean it, of course, using all the alternatives just to improve your programming skills as well as your logical thinking. Once we clean it, then we are trying to featureize this data and we will extract some set of features and to understand our data very well and to showcase some meaningful insights. That's what we will do, especially in all our upcoming session. So that's all about this session. Hope you love the session very much. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session, what we have done is we have just understand our data, of course, our missing values and all the features that we have. So in this session, what we have to do is we have to perform data cleaning on top of this parrot feature, as well as we have to perform feature engineering on top of this parrot feature as well. This is one of the most complicated tasks in the entire data analytics life cycle. So inside this parrot feature, if you will figure out, let me show you where exactly we have that feature. Yeah. This is exactly that feature that we have. So first and foremost, we will clean this feature. This is the very first step that we will do. Then we will featureize this data. And after feature engineering, we will extract some set of features from this parrot features. That what we will do. Of course, set of features will be like what is my minimum parrot? Let's say this is the very first feature that I would love to extract it. The second one is what is my maximum parrot? This is the second feature that I will extract from this parrot feature after cleaning. That's what I will do in this entire session. Of course, it takes lots of your expertise, not just in Python, on the various aspects of Python, like how to clean this parrot feature using multiple ways. Because if we will try to solve a similar problem statement from wide spectrum of things, it will improve our programming skills as well as it will improve our logical thinking. That's why we will primarily focus on the problem solving skills in this entire course, just to improve your logical skills as well as your programming skills, because that's what you really need in the real world. Because in real world, your programming and your logical skills matters a lot. These are the key skills where you have to focus more. So if I will say, let's say, what is my parrot feature? So I'm going to say df of parrot. Very first we have to access it. And if I'm going to say, let's say head of 20, let's say I have to visualize the very first 20 observations of my parrot feature. Now you will see inside this parrot feature, this is my nothing but my minimum parrot and this is nothing but my maximum parrot. But again, these are those rows that will create problem for us. So anyhow, we have to clean such observations which are nothing but my not disclosed by recruiter, and we have lots of observations like this one. So let me show you how you can extract minimum parrot and maximum parrot, let's say, from this observation. So what I will do is I'm going to say df of parrot of, let's say, 0th observation. So this is exactly my entire parrot. Now on top of this, if I will say, hey, can you split this string into list? So I can use just a split function and I will say, I will split it considering this separator. And if I will execute, you will see this is my minimum parrot and this is my maximum parrot. Now to access your minimum parrot, I will say just pass 0th index. Similarly, if we have to access my maximum parrot, I will say, hey, I will just pass my index 1. And this is the maximum parrot that you exactly need. But again, inside this parrot feature, we can have lots of anomalies. Let's say, hey, let's say I have some observation as, let's say, 1K to 5K, let's say to 8K. If I have such kind of observation, this logic makes no sense. Whatever I have written over here, this logic makes no sense. Because it makes no sense having such observation. So we need to clean such type of data, and to clean it, we have to use both logical and of course my programming skill. So in a nutshell, if your pay rate has a length of 2, if it has a length of 2, it means it has a minimum rate or minimum pay rate and it has a maximum rate. If we have a length as 2, that is my valid entry. Apart from length 2, whatever we have, that are exactly my invalid entry. Now we have to find out how many we have invalid entries and how many we have valid entries inside this pay rate feature. It means with respect to each and every observation, we need to count what exactly its length. This is what we have to do. So I'm going to say for pay in df of pay rate, I will extract each and every pay from this df of pay rate. Now once I have this pay, now on top of this, very first I have to convert this into a string, because only string has this inbuilt function of split. Now I will say str of pay dot, I will just call this split function which is defined inside my string class, and this is exactly that function. Now over there I have to mention this separator. Now on top of this I will say, let's say just compute its length. And whatever length I have obtained, let's say I have to store that in, let's say, list. So very first I have to define that list, let's say lan underscore pay. So I will say this is exactly my lan underscore pay, and whatever length I have obtained, I have to append in this lan underscore pay. So I will say dot append. Now what I will do is I will just execute this line of code, and if I'm going to say lan underscore pay, and this is exactly that list, and if I will print it, you will see these are all the length of the list or the length of the observations you have as an element in this list. Now what I will do is I will say, hey, can I convert this into a series just to count what are all the unique elements in this list along with its count. So for this I have to just call a function which is exactly value underscore counts. So if I will execute this line of code, you will see with respect to one count, you have 17k data points, of course more than 17k data points. Now with respect to 2, these are my valid entries that we have to take care of it, and these are all my invalid entries. Of course these one and these one, they makes no sense in the entire analysis. So what we will do is, there are two ways to handle this. The very first one is either you can drop all these rows, but again this is not a optimal way in the real world. The second one is you can think of some optimal solution. So what I will do is I will say, hey, let's say I will create some set of features, let's say with respect to pay rate. If I will featureize this feature, or if I will extend this feature, I will say I will split this feature into multiple features. Imagine I have a pay rate as, let's say 1k, 4k, 9k, or let's say 16k, and let's say here we have, let's say, some special character. Let's say I have such pay rate. So what I will do is I will say I will create 5 features just to store this observation, like this one. So I will say 1k will be over here, 4k will be over here, 9k will be over here, 16k will be over here, and my special character will be over here. That's what I will do with respect to this observation. In a similar way, we have lots of observation in this pay rate feature, and we have to do all these tasks for each and every observation. So to do this task, there are two ways. The first is you can think for code completely from scratch using your own skills. The second is you can take advantage of your string class, because in string class, just to use this functionality, we have an amazing function. What we are using over here, that is nothing but my split function. I will just split this string considering this separator, and I will store all the values, and I will store all these values. So I will say df of pay rate dot str dot split. Here we have to mention what is exactly my separator. then I have to use one more handy parameter, which is exactly my expand parameter, because we have to expand this paired feature into a set of features. So I will say expand is equals to true. By default it is false. And if I will execute this line of code, these are all the set of features that you have to take care. Now what I will do is I will say, hey, let's say, can you store it in some, let's say, parent underscore split. This is exactly my new data frame where we have to store all the parent features or set of features. Let me just execute it. And if I'm going to say parent underscore split, so this is exactly the data frame. So from this parent split feature, we have to take care of this 0th feature and this first feature, because they primarily holds my minimum parent and my maximum parent. They hold all the values, because we have figured out whosoever parent has a length of 2. These are all the observations that we have to take care. Again, that's why these are those rows that we have to take care. So what we'll do is we need to clean this 0th feature, or we can name it as, let's say, minimum, and 1, let's say, maximum. So we need to clean this 0th feature and the first feature. So the very first cleaning that you need to do is you need to remove this comma, because it makes my integer data into string nature. So what I will do is I will say the very first cleaning that I have to do is I have to remove my comma, and later on I will do more cleaning. But very first, let's figure out whether we have extra white spaces in these features or not. So what I will do is I will say parent underscore split. I have to, let's say, access this 0th feature, and let's say if I will say let me access 0th observation. Now you will see we have some extra white spaces over there. So what I will do is the very first cleaning that we have to do, we have to remove all the extra white spaces either in the left side or in the right side of the observation that you have. The very first thing that I'm going to do is parent underscore split. Very first we have to access the 0th observation. Now on top of this I will say .str.strip. It will strip all the white spaces that we have. And what I will do is I will say, after doing all these things, I will update this 0th column as well. Let me just execute. Now we have to remove comma from this. So I will say on top of this I will say, of course, .str.replace. Now what we have to replace? We have to replace basically my comma with this one. I will say just replace my comma, and if I will execute, these are all the set of values that you will get. Of course, there is one more way to replace this comma. Of course, you can think of using your lambda approach. So what I will do is I will say, let me very first copy this, and I will say on top of this, what I will do is I will say just apply. Now what we have to apply using lambda keyword, I will say on each and every observation, on top of each and every observation, I will say x dot replace. Now I will say just replace this comma. That's it. Of course, you need to make sure that whatever x over here, that must be of string nature. So I will say just convert it into some string, because imagine if we have some missing values in this feature. So of course this x belongs to my float nature. That's why we have to make sure that it must belong to your string nature. And if I will execute this cell, now you will see these are all the values what you have obtained over here. These are a similar code, but again both has its own pros and cons, and both are extensively used in the real world. Now I will say let me update this feature as well. So let me just execute, and if I'm going to say 0th, and this is the data that you still need to clean. So in the next session, what we have to do is we have to find, see over here you will see we have some float values, or you can see these are my integer values. But along with some integer values, we have also some string values. So what we need to do is, very first we will try to figure out whether we have some float values or not. Inside this feature. And if it is float, we will try to separate it out. That's what we will do. Of course, just to find this float values, we will try to find out all the ways just to find how to find the float values inside any feature that you have. We will learn all the possible ways to do it. So that's all about this session. Hope you love this session very much. And if you guys have any doubts and any issues, feel free to drop a query in the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session, what we have done is we have basically cleaned up to greater extent, not up to greater extent, but yeah, up to some extent, we have cleaned this paired feature. And of course, we have extracted some set of features from this paired feature. And as well as after this, what we have done is we have just removed all the extra byte spaces, as well as we have removed all the commas wherever we have. That's what we have done in the last session. So in this session, what we have to do is wherever we have float values, we will say wherever we have float values or wherever we have some integer type values, because these are nothing but my minimum pay. These are nothing but my minimum pay, and we have to extract it, or you can see we have to separate it out from these all the features. Again, just to separate it or just to do manipulation, there are tons of ways. So we will learn all the ways, of course, all the possible ways. So the very first one is you can think of using something known as exception handling, where I will put my simple try and accept block. Inside this try block, I will simply put some of the condition, let's say some if condition, and if exception occurs, just pass that exception through this except block. That's a very layman explanation of this exception handling. The second way is you can think of using regular expression. Again, this is one of the extremely used ways in the real world. This exception handling, this regular expression, these are some of the best practices in the real world. Again, using regular expression, I will say, hey, I will define some kind of pattern. I will define, let's say my pattern is, let's say X. Then I will say, whosoever feature will not follow this pattern, just eliminate that. That's what my regular expression will do. The third approach is we can use some inbuilt functionality. Let's say we can use some two numeric function of pandas. This is one of the inbuilt function that you can think of if you are good with data manipulation, of course with pandas. This is the inbuilt function inside my pandas module. And the fourth way is you can use any function along with the map function. We will discuss all these things, how you can use that. We will discuss all these things, of course. So these are typically these are the four ways. Of course, there are some more other ways, but these are the most extremely used ways in context of real world. So the very first approach is your something known as exception handling. So in this, what we will do is very first we will just add our some try block. Inside this, I will put a simple if condition. If data type, let's say if d type of pay rate, if d type of the pay rate is float, if it belongs to float data type, then I will consider this pay rate. Else, it means we have to go into this except because we have this exception. Then I will say this is my missing value. Let's say I will say this is my missing value, or I will eliminate it, whatever you term it as. I will say I will eliminate it. So let's try to code this, of course, using Python. So basically I am going to say for pay rate in whatever pay rate we have. Now I will simply very first put my try block. Then I will say I have to put my if block, or I have to put my if condition. Inside this if condition, very first I have to convert this pay rate into my float data type. So I will say float of pay rate. Then I am going to say if its type gets equals to my numpy dot float. If this condition is true, then only I will consider this pay rate in my list. So very first I have to define that blank list. So I will say this is my blank list. So I'm going to say pay dot append. What we have to append? We have to basically append this pay rate, whatever I have extract from my for loop. So this is exactly my very first one. Now imagine this will this block of code will create some kind of exception for us. So in such case, we can think of for my except block. So I will say except. In such case, what I will say is, I will say in such scenarios, I will say just append, let's say, missing value. So I will say just append a missing value. And if I will execute this line of code, now you will see you have a syntax error. Now let's understand what this error is all about. It will say, hey, you have an invalid syntax. Now what you can do is, you will see here you don't have a proper indentation. Again, Python is a case sensitive, not just case sensitive, it is one of the extremely sensitive programming language. So you have to take care of all the errors, whether it's a syntax error, whether it's a logical error, or whether it's a runtime error, whatever error you have. So I will say very first, let me provide correct indentation. Now all the stuffs are okay. Let me again execute. But before that, you have to say this is exactly must be in the form of string. And if I will execute this line of code, you are just getting some warnings. And if I'm going to say, hey, can you return me, let's say what exactly you have in the pay. Now you will see you have all the values over here. So apart from your float or integer values, whatever you have, you can term it as missing or whatever you want. Again, the second way is you can think for your toNumeric function. So what I will do is I will say pd.to_numeric. You can use this function. Over there, what I will do is I will say pay rate of a split of 0. Over here, if I will press shift plus tab, here we have to take care of one more important parameter, that is errors. It means if we have any observation that is not suitable for this function, in such case I can say I can skip that observation. So for this I have to use a parameter which is exactly my errors. So inside this errors I will say just course all the errors. And if I will execute this line of code, now you will see these are all my float values, but these are all the missing values because these are those observations that are not following the protocols of this toNumeric function of pandas module. So our third way is exactly my regular expression. See, regular expression is extensively used when you have to deal with your text type of data. Extensively used. This is widely used across different spectrum. So what I will do is I will say I will just define some kind of pattern. Then I will say whosoever observation will not follow this pattern or will follow this pattern, then I will do some kind of operation. That's what I will do. So I'm going to say very first we have to define some pattern. Then I will say whosoever observation will follow this pattern, just skip that observation. So in a nutshell, I will write a pattern for especially my all the string type of data. So anyhow, we have to write a pattern for such type of data. So what I will say is, I will say the very first one is this one. It says accept digit. Then I will add a dot. Dot especially means any character except the new line. Then I will add this quantifier. This is exactly my quantifier. These are the keywords of your regular expression. So this pattern simply stands for, see, this basically stands for if it starts from anything else other than digit. That is simplest meaning of this /t. Then we have this dot that says after this we can have any number of characters. Then this basically says I can have 0 or more repetitions. That's a very layman explanation of what we have. Imagine we have a, let's say this string, let's say missing value at index, let's say 4 or 5. Let's say this is my entire thing at some observation, and I have to match it especially with my pattern, whatever I have written. So basically, very first I will come up with this one. Now you will see this is not my digit, so it means it will follow this. Then you can say I have a dot which says, of course, I can have any character except the new line. Then I have any set of character, except a new line, because we don't have a new line. This is just my entire string. We don't have a new line. Then this I will follow this dot. Then We have this, of course, this star, that is exactly stands for 0 or more repetitions. Again folks, we have repetitions of the characters in this entire string. That's why it will match whatever pattern I have written over here. So of course, the third way is extremely used in the real world if we have text type of data. In such scenarios, you can think of, because we have text type of data. But let's say if we are going to perform some natural language processing task, in such scenarios, this regular expression is extensively used. So let's try to implement all these things. So very first, let me define my pattern. So my pattern is exactly nothing but, very first I have to use this, then dot, then I have to use my quantifier. This is exactly my entire pattern. Now what we have to do is, I will say on top of this, I'm just going to call dot str dot replace. Then I will say what we have to replace. I will say I have to replace my pattern. Of course, just replace this pattern. That is the exact meaning of whatever we have written. And if I will execute this line of code, now you will see it return us only my float values. You will see, or integer values, because it will skip all those observations wherever this pattern gets matched, and that's what this pattern will do for us. So let's try to use some extremely good ways, some advanced ways, slightly advanced ways, just to find all the float values, or to find all the integer value, or to find whether we have float values inside this paired split or not. Let's say we have to find this, we have to just find this whether we have float values or not. So in such scenarios, we can think of using our fourth way, where we have to use our any inbuilt function along with my map function, which is of course a inbuilt. So what I will do is, I will say very first we have some kind of function, and I will say I have to apply this function on top of any data. Imagine my data is, let's say this one, let's say split of 0. Imagine this is the data on which I have to apply some function. So to apply a function on each and every observation of this split of 0, you have to use something known as map. Of course, that's what we have learned in all our previous sessions of previous use cases. You have to use this map. So what it returns us, basically, it just returns us some kind of iterator. Now what I will do? I will say, hey, on top of this, I will call this any function. So internally what it does is, it says it will return true. It will return true if any item in an iterable is true. Otherwise, it will return us false. That's what my any function will do. Again, this is slightly more advanced way. Again, you can think of using this, of course. So let's try to do is, of course, using Python. So very first we have some kind of function. So I will say, let's say my function is nothing but str dot is digit, or you can also use is numeric. So this is exactly my function that we have to apply on top of this paired split of 0. So what I will do is, I will say I have to apply this function on top of this. So to apply this, you have to use a map keyword. This is what I have done. Again, now it will return us an iterator. Now what I will do is, I will say I will just call any on top of this. If an item in this iterable is true, it just return us true. If not, it will return us false. And if I will execute this line, so you will see it will return us, of course, true. It means, yeah, we have some kind of digits, or we have some kind of numeric features inside my paired split of 0. That's a very layman explanation of what we have written over here. Again, this is just a one-line code, but of course, it is slightly advanced. In a similar way, we can also think of using some more functions of a string class. Let's say is numeric. So I'm going to say is numeric of this, and let me execute. Again, you will see a similar result. It means both functions are doing our task for whatever problem statement we have over here. So in the upcoming session, what we are going to do is, we will also try to manipulate this paired split one feature as well, and we will do all these kinds of pre-processing on top of this feature as well. And then we will append or we will insert both the features inside my main data frame. That's what I will do in all our upcoming session. And after that, we will clean our other features, like of course my experience feature as well. That makes a lot of sense in this entire data, because of course this is a sample of the real world data. So that's all about this session. Hope you love the session very much. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session what we have done is we have basically performed data cleaning on top of this 0th feature of this pay rate underscore split data frame. Because in nutshell, this is exactly my minimum pay rate and this is exactly my maximum pay rate. And we have to consider both the set of features, and what we will do is we will try to clean this, of course, and once we will clean it, we will try to append both the features in my data frame. That's what we have to do. So in all our previous session, we have cleaned this minimum feature. So let's try to clean and pre-process this maximum feature as well in this entire session. So just to clean this first feature, often known as maximum pay rate, itself consider 4 major steps. So the very first step is, let me consider, let's say this one data point or observation. So imagine you have some, extra white spaces. So in such case, you have to remove all the extra white spaces if you have. The second thing is, here you have some comma, because your end goal is just not to clean it, you have to also convert this string value into something known as integer, because this is exactly my special character, and wherever we have a special character, that is exactly belong to my string class. So we have to convert this from string to integer, and to convert this string to integer, very first we have to remove this comma. So what we will do is we will say, hey, can you remove the comma? This is exactly my second step. And in third step, what we will do is we will remove all the values wherever we have none or any other set of characters. So in third step, we will say, hey, can you remove all the set of characters that you have in your first feature or in your maximum pay rate feature. In the fourth step, we will just convert its data type from object. If it is object, we will convert this into something known as float or integer, depending upon the values we have in maximum pay rate. Typically, we will convert it into float, but if we have the values in integer, so we can also think of this. That's not rocket science. So typically, we have all these 4 major steps just to clean this maximum pay rate feature. So your very first step is you have to remove your extra white spaces if you have in your data. So let me show you that. Very first, let me show you that. And if I will say, let me just copy this and let me say it is exactly this one. And if I will execute, you will see these are all the values. And let me access data of, let's say, 0th index. And if I will pass 0 and if I will execute, you will see we have some extra white spaces over here. So let's try to remove wherever we have extra white spaces. So what we will do is we will say, hey, can you mention the 1? And over here, can you mention 1 as well? So I will say exactly, why not? So let me just execute this line of code. So once you will remove your extra white spaces, your second major step is you have to remove something known as comma, because your end goal is to just to convert from this object to float. You have to do all these pre-processing steps over here. So what we will do is we will say, hey, in this first feature, or often known as maximum pay rate, can you remove this comma so I can use all these blocks of code that we have already written with respect to minimum pay rate feature. So I will say that's all about this. Let me just execute this line of code now. What we have to do is we have to say wherever we have set of characters, can you remove it? So of course we have done it using lots of approaches. Again, if you can do it using lots of ways, it will just not improve your programming skills, it will also improve your logical thinking. So we have done it using exceptional handling where we have written all these blocks of code. Then we have also do it using something known as toNumeric function. Of course, that is an inbuilt function inside my pandas module. The third way is you can think of using your regular expression. Of course, the fourth way is you can think of using your any function along with your map. This is, of course, this is little bit advanced way, but again, this is one of the optimal way. if you are thinking for a top product based companies. So let's try to use this regular expression approach, and we will say this time we will use on top of our maximum pay rate feature. So here we have to just mention this one, that's it. So we will say, let me just update this first feature as well, and let me just execute this line of code. And if I will say, let me show you all these values, of course. And if I will say, let me show you all these values. Over here, you can say these are all the values, and wherever we have such a pattern, let me show you what we have pattern. So this is exactly the pattern that we have. So, or what you can do, you can mention this pattern as well. So this is exactly that pattern of which we have already touched upon that. Now, once I have pre-processed all these stuffs, let me check what exactly is the data type, of course, of this feature. So what we will do is, let me say, I'm just going to say pay rate underscore split dot dtypes, just to call this inbuilt function. You will say the zeros feature has object data type, of course. The first feature, which is often my maximum pay rate feature, is also considered as an object category. So we have to manipulate its data type as well. So what we will do is, we will say, can you just call a function which is exactly my 2 underscore numeric. So I will say 2 underscore numeric, you can just press tab, and this is exactly that inbuilt function. So what we will do is, if I will press shift plus tab, you can check out all the documentation of this function. What it will do is, it will just convert some argument to the numeric type. That's what my function will do for us. So over here, what we have to mention is, I'm going to say pay rate underscore split. Very first, we have to access this data frame, and I'm going to say I have to manipulate this zeros feature. And over here, wherever I have any kind of error, I'm just going to say I will just skip wherever we have any kind of error. So I can use this course parameter. Similarly, we have to use again this similar block of code, but this time I have to do for my maximum pay rate feature. Of course, that is exactly my first feature. So now what we will do is, we have to update both the features. So I will say pay rate underscore split. Over here, we have to just mention this zeroth feature. Similarly, I am also going to say I have to do, of course, for my first feature as well. Now, once I will execute this line of code, and if I'm going to say pay rate underscore split dot dtypes, and if I will execute this line of code, you will see now it belongs to your float category. Now my task is done. Now what we have to do is, we can insert our minimum pay rate feature, and our maximum pay rate feature is exactly in my final data frame, that is nothing but my df data frame. Now that's what we have to do. Again, just to do this, we have two approaches basically. The very first one is, you can think of using your concatenation approach, and you can basically call a function known as concat function that is defined inside my pandas module. This is your very first approach. The second way is, you can define some new columns in your data frame, of course in your df data frame, as let's say minimum pay rate, and you can assign your pay rate underscore split of 0. This is your second way. Again, both the ways has its own pros and cons. Imagine you have 20 new features. Imagine you have 20 new features. So if you are going to use the second approach, it is not handy, because imagine you have to write 20 lines of code over there. Again, that's not an optimal way. But again, if you have some few features, let's say 4 to 5, of course you can think of using this. But again, if you have more than 5 to 10 features, or let's 20 or 50 features, again in the real world you can have, imagine you have set 100 features. So in such case, it is always good to use this concatenation approach. So what we are going to do is, we are just going to use this concatenation, as well as, just to show you, we can use both the approaches. So I'm going to say df of, let me define a new feature, let's say minimum underscore pay. Imagine this is the feature, and it will hold all the values of this zeroth feature. And the second feature that we have to define, let's say max underscore, let's say pay, and it will hold all the values of this first feature. And if I will execute this line of code, and if I'm going to say, let's say df of head, let's say 8, and if I will execute this line, now you will see we have two more new features, which are exactly my minimum pay and my maximum pay, because we have extracted both the features itself from my paired feature. This is your first way. The second way is you can think of using your concatenation approach. So I'm going to say basically pd.concat. Here we have an inbuilt function. Over here, if I will press shift plus tab, that's all about the signature and my documentation of this function. You can just follow it. That's not a rocket science. So what it will do is it will just concatenate my pandas objects along a axis, whatever axis you want, with some other thing as well. So what I will do is I will say, hey, can you concatenate my paired underscore split of 0th feature, and can you concatenate my first feature as well? Of course, over here my axis will be 1 because we have to concatenate in a vertical order. So I will say axis equals to 1. Now, or here I will say we don't want shorting, so I can say short equals to false. And if I will execute this line of code, so this is the data frame that I have get over here. So what I will do is I can just concatenate this data frame, whatever I have achieved over there, to my df1. So let me show you that. If I will say, let's say this is exactly my pay, and I'm going to say pay dot columns. The very first is exactly, let's say, minimum underscore pay. This is my very first feature. The second is, let's say, maximum underscore pay. Of course, let me say it is exactly my maximum underscore pay. Now once I will do it, I'm going to say let me print my pay, and this is exactly my pay data frame. Now what I will do is I will say pd dot, I have to again call this concatenate function. Over there, now what I'm going to do is I'm just going to mention my df along with what is my pay data frame. And now I'm going to say axis equals to 1 because we have to concatenate in a vertical order. Now I'm going to say short equals to false, and if I will execute this line of code, now you will see over here, let me show you that. Now you have two more new features which are exactly my minimum pay and my maximum pay. Again, this is the similar feature that you have achieved by defining two new columns, and these are those features that you have achieved using your concatenation approach. So in a nutshell, the rule of thumb is if you have less feature, you can define some new columns in your data frame and you can just insert it. But again, if you have more number of features, always think of concatenation. That's a fairly good approach than defining new columns and just to insert this. So in the next session, what we will do is we will also try to clean this experience feature, as well as we will try to featureize this experience feature, of course, into minimum experience and into maximum experience. That's what we will do, especially in all our upcoming session. So that's all about this session, and if you guys have any issues, any doubts regarding this session, feel free to drop us a query in the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session what we have done is we have basically cleaned this paired feature, as well as we have featureized this feature into two set of features, of course my minimum pay and my maximum pay, and we have gone through all the several steps of data cleaning, how to featureize it, of course not just from one way, using all the alternatives that we have. So in this session what we have to do is, our problem statement is all about, what we have to do is we have to just clean data and we have to perform this featureization on top of our experience feature. So let me very first have a look on what exactly my experience feature is all about. If you will figure out, this is exactly my experience feature, and these are all the values, let's say 0 to 1 years, 0 to 0 years, that is exactly my dirtiness in my data. 4 to 8 years, 11 to 15 years. So these are all the set of values. So from this experience feature, what we can do is we will just clean this feature. This is our very first step. Then we will try to featureize this data, or we will try to apply something known as feature engineering. Once we will apply this feature engineering on top of this experience feature, we will say, hey, can you extract a minimum experience and can you extract a maximum experience features itself from this experience features. So in a nutshell, what we have to do is we have to extract these two set of features just itself from this experience feature. So once we have this set of features, we can analyze our data in much more depth. So this is exactly the problem statement that we have to do. Again, just to do this step, just to clean the data, just to featureize this data, we have plenty of ways, and we have learned all the possible ways, especially with respect to parrot feature in all our previous session. That's what we have done, especially in the previous session. So basically, from this observation, my minimum experience is 0 and my maximum experience is 1. This is the set of feature. This is exactly my minimum experience and this is exactly the maximum experience. So what we will do is, we will just define one more feature inside this df data frame as, let's say, minimum underscore experience or experience underscore minimum and experience underscore maximum. Let's say these are the set of two features that I will create, and I will just append the values depending upon the observation that we have. That's what we have to do in a nutshell. So what we will do is, on top of this is exactly my string data. So to convert this string data into something known as list, because I need value as 0 and 1. It means what I can do is, I can store this data in list, and to convert your data and to convert your string data into list, you can think of something known as split inbuilt function. This is an inbuilt function available in my string class. So I will say, hey, can you split my string having some dash as your separator? This is exactly my separator. Or you can say, on the basis of the separator, can you split your string? And this is what my split function will return us. It will just return us a list storing all the values that are typically separated by this separator. So very first, what I'm going to do is, I'm going to say, let's say df of experience. You can just press tab and that's all about my feature, which is exactly experience feature. Let me execute. These are all the values that we have. Let me access data of 0th index. So this is exactly data of 0th index. So what I will do is, I will just, let's say, copy this observation and let me store this observation somewhere else. So I'm going to say, let me store, let's say, in value. So I'm going to say that's all about my value. Let me execute. Now on top of this value, if I will call something known as my split function, so I will say value dot split, and I will say, can you split this string having this separator? And if I will execute, you will see you will get two values. This is exactly a 0, which is my first element in this list, or you can say this is at index 0. So just to access it, you can pass index 0. That's not a rocket science. You will see this is your minimum experience. So just to access your maximum experience, what you can do is, you can just pass an index as 1. Let me execute, and this is exactly your maximum experience. So what we have to do is, we have to do this similar task again and again for each and every observation. So why not just create a function for this? So I will say, let me define a function, imagine split underscore experience, and whatever x or whatever observation it will receive. On top of this x, what it will do basically is, it will say experience, or you can say, let's say this is my experience. I will say, let's say this is exactly my experience. So this is my experience. Now on top of this experience, very first I will say experience dot split of 0. Now again I'm going to say experience dot split of 1. So this is exactly my minimum experience. So I'm basically going to say this is exactly my minimum experience. In a similar way, this is exactly my maximum experience. Now what we have to do is, we have to just return it. So I'm going to say, let me return my minimum experience, the very first one is, and then we have to return our maximum experience as well. Let me just execute this line of code. Now what we have to do is, we have to just call this function, which is split underscore experience. And let me cross check whether this function working right or not. So for this, we have to just pass the value that we have stored over there. So I will say, let me just check this function for the value that we have. So it will basically return this 0 as your minimum experience, and of course this is as your maximum experience. Cool. So let's try to apply this function on top of your experience feature, and let me check whether this is working or not. So what I will do is, I will say df of experience dot apply. Now what we have to apply is, we have to just apply this function what we have defined. Let me just execute this line of code. Of course, it will take a couple of seconds, and let me check whether we have any error or not. Now you will see you are getting an index error. Let me check it. So according to this error, we have an index error that says your list index out of range. It means the function that we have defined is not working for each of the index that we have, or for each of the observation of the experience that we have. It means again, we have to clean this experience feature much more than only we can think of applying this function. So let's try to think first, what are all the possible cases in which this function will not be handy. Again, if you will see, this function typically works if we have data, let's say 0 to 1. Let's say, let me remove this. Let's say I have a data as, let's say 0, 1. This is my minimum experience and this is exactly my maximum experience. But imagine I have some of the rows where my experience is, let's say 1, 2 and let's say 3. Imagine this is the observation at some index, let's say at 100. So in such case, if I will apply this function on top of this observation, it will give some kind of error. It means I have to find all the rows. Let's try to find all the rows where I will receive any kind of error. Again, there are multiple scenarios, there are multiple observations where this function will throw an error. Imagine if we have some rows, imagine where my experience is, let's say, not available. So in such case, I will also face an error. Again, there are tons of ways, there are tons of approaches just to find in which rows we have some kind of error. One way is, what you can do is, let's say you can just iterate on top of each and every experience, and then you can add a filter as if length of any observation of experience or length of observation will not equals to 2. In such case, I can say this observation is throwing some kind of error. Because if you will figure out, if we have an experience as 0 to 1, so this is my valid observation according to the function that we have defined. But imagine we have observation as 0, 1, 2. So of course, its length is not 2. So this is that row which will throw an error. Imagine we have some, let's say 0 to 1, or let's say some special character as, let's say this and let's say this and this. Imagine this is the observation. Again, this is the observation that is also throwing some kind of error. Imagine we have some values and let's say not available or not defined. So these are all the set of values which are not following this condition. So I'm going to say for experience in df of experience dot drop any. Let me very first drop all the missing values that we have in experience. Now I'm going to put a condition if length of experience dot split, and over here what we will do is we will say very first you have to split it considering this separator. If its length is not equals to 2, then only I have to consider that observation as my dirty observation. So let me just store that observation in somewhere else. So let me just store, let's say, this observation in some list. So very first we have to define that blank list. So I'm going to say len1 as this much. Now what I will do is I will say len1 dot append. Now what we have to append is we have to just append this experience. Now let me just execute this line of code, and if I'm going to say let me just print len1, now you will see these are all the set of rows that are especially throwing some kind of error. You will see we have tons of values as not mentioned, and again you will see our experience as 3. You have especially 2 separator as this. Again, it can be -1 or it can be your separator as well. So this is exactly a type of dirtiness that you have data. And again, these are some of the real world things that you might encounter in your real IT challenges. So what you can do is there are 2 ways to solve this. The very first one is you can drop all these rows wherever I have such kind of entries. The very first is you can drop or you can delete. This is the very first way. Again, this is not a handy approach in a real world. But again, if you have small data, you can think of using this approach. So the second one is, you can think of using some optimal solution. Again, this is one of the most recommended approach if you really want to build your skill in the real world. So in the upcoming session, what we will do is, we will try to understand all the optimal ways how to tackle this problem in the real world. So that's all about this session, and if you guys have any issues, feel free to drop a query in the Q&A of the course. Please feel to drop a query. So that's all about this session. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session what we have done is, we have figured out here, in the experience feature we have some kind of dirtiness available. Of course, these are all the rows that are giving some kind of error as a index error, or you can say list index out of range. And we have figured out these are all the set of observations that are throwing some kind of error, because our main goal is to just not to clean this feature, which is my experience feature. We have to featureize it as well into minimum experience as well as into maximum experience. So to deal with this scenario, there are two ways. The very first one is either you can drop all these rows. Again, this is not a handy approach in the real world. The second way is you can think of using some optimal way, some optimal approach. So the very first way is you can think of using a split function on top of our experience feature. That's what we have done, especially in my paired feature. Again, let's try to use some another approach. Of course, you can enhance the functionality of our function, our custom function, which is a split underscore experience. We will try to enhance the functionality. Again, now you can think how we can enhance the functionality of this custom function so that it will handle this scenario as well. So what you can do is, you can add something known as exceptional handling in such case, just to handle all these rows. So what we can do is, we can introduce our exception handling code inside my split underscore experience function, and we will say, if any kind of exception will occur, just come inside except block, and in except block we will add some functionality. If we do not have any kind of exception, just execute to try block. That's what my exception handling will do. So what we will do is, we will say, this is exactly my function what we have written. I will say this time this function is, let's say, split underscore experience 2, and now I have to add a exception handling code inside this function. So very first I have some try block, then we have to provide a proper indentation because Python is case sensitive. Now I will add my if block. So over here I will say, if its length, whose length, observation length will be equals to true, in such case just execute this line of code. So I will say experience dot split. Over here I have to split it considering this separator. If its length will be equals to true, in such case just execute all these lines of code. That's what my try block will do for us. Again, you have to write that code as well when your exception will occur. In such case, what I will do is, I will say, I will just return numpy.nan or missing value. Similarly, numpy.nan. That's what my exception handling will do for us. So let me just execute this line of code. Now what we will do is, let me just copy all these blocks of code, which is exactly this one, and I'm just going to say, let me just again execute this line of code. This time my function will be experience 2. Let me just execute this line of code. Or let's say I have to increase its functionality a little more. So what I will do is, I will say, I will just return my data in the form of series data structure so that I can append this series in my df data frame easily. Similarly, I can append, instead of missing value, I can append data in the form of series. So what I will do is, on top of this, I will just say pd.series. Again, series is exactly your one-dimensional data structure in your in your pandas module. So I will say this is all my data is exactly in the form of series. Similarly over here, I'm just going to say pd.series. Similarly over here, I have to enclose very first all the stuffs in list, then it will return us all the series. Then we have to just execute this line of code, and let me again execute this line of code. So of course it will take a couple of seconds just to load this, because again in the backend all the exceptional handling code is still executing. Now you will see what you have achieved is you have all the data. This 0 is exactly my minimum experience and this 1 is exactly my maximum experience. Now let me show you one more thing. Let's say I will try to find out all these rows where I have all these raw observations that doesn't work for my split underscore experience function. So let's try to find out all those rows. So I will say, let's say df of experience. Very first we have to access our experience feature. This is my feature. On top of this I will say .str.contains. Now what we have to contain? We will say we have to just contain this. Let me execute and this will exactly return me in the form of boolean data. Again, we have all data as false and true. So wherever it will return us false, it says at this index, we do not have any string as not mentioned. So what I will do is I will say, why not just create its data frame? So I will say pd.dataframe and let me just enclose this in the small braces. Let me execute. And what I will do is I will say this is exactly my enum, not mentioned. Again, let me just print my enum data frame as well. And I will say enum of experience, this is exactly experience, equals to true. Let me just add my filter. So this is exactly my filter and I have to pass this filter in my enum data frame. And if I will execute, these are all the observations where my experience is true. It means at all these observations, I have a string as not mentioned. Now on top of this, if I will call .index, it will return all the indexes where my not mentioned string is available. Now what I will do is I will say, let me very first say df of experience. Very first we have to access it. Now over here I will say 1138. This is exactly index. Now you will see at this index I have a data or I have an experience as not mentioned. And if I will pass this data inside my split underscore experience to function, let me show you. And if I will execute, it will exactly return me a NaN value. It means if we have this scenario, now my function is able to handle that scenario. That's what we really need. So over here, what we will do is we will try to rename the column names. So I'm going to say .rename. And over here, we have a parameter which is exactly columns. So I will say columns, and how we have to rename? We have to rename using our dictionary. So using dictionary, I will say just replace 0 to my minimum experience. I will say just replace 0, of course, to my minimum underscore experience. Then I will say just replace 1 with my maximum experience. And if I will execute this line of code, now you will figure out we have minimum experience feature and we have maximum experience feature. So let's try to insert in your data frame. So what I will do is I will just define 2 new features just to insert both the features in your df data frame. So the very first feature is exactly your minimum underscore experience. The second feature is exactly your maximum underscore experience. Now what I will do is I will just execute this line of code. And over there, if I'm going to say df.head and let me pass some value, let's say 3. And if I will execute this line of code, now you will see now we have 2 more new features which are exactly my minimum experience and we have some maximum experience. Now from this maximum experience, what we can do is we can say, hey, we have years. So why not just replace this year, or why not just make this observation 1 years as 1. So for this, very first we have to access our max underscore experience feature. On top of this, I will say .str.replace. Now what we have to replace? We have to replace YRS, especially this one. Similarly, we have to update this experience as well, or maximum experience as well. So let me just execute this line of code. And if I'm going to say df dot had, let me pass some value and let me again execute. Now this time you will see you do not have any years as substring in your maximum underscore experience feature. Now let me check what exactly its data type. So for this we have to just call this dtypes, let me execute, and you will see right now both the features belongs to object category because we have extracted both these set of features itself from this experience feature that already belongs to object category. That's why this set of feature also belongs to object one. So I will say df of maximum experience dot s type. Over here we have to say let me convert this into float. Similarly we will say minimum underscore experience dot s type. We have to just convert this into some float values, and I will say let me update my maximum underscore experience and let me update my minimum underscore experience. I will say this is exactly minimum underscore experience. Let me execute, and if I'm going to say df dot dtypes, let me again execute. Now you will see now both the set of features belongs to my float class. Now what we can do is from this set of features and from this set of features we can create one more features. Let's say, hey, can you create a new feature as average pay, which is nothing but a average of minimum pay and a average of maximum pay. In a similar way, can you create one more feature as average experience, which is all about my average of this minimum experience and maximum experience. So can you create both the features, and we will consider both the features again to understand our data in much more depth. So basically I am going to say df of very first we have to access very first minimum experience, and we have to add all the values of maximum underscore experience, and what we will do is we will try to very first enclose it, and we will say just divide all the values by 2. Let me execute. These are all the values that are exactly my average experience. So why not just store it? So I will say this is exactly my average underscore experience or average underscore exp, whatever you want to mention. In a similar way, let's try to do with respect to my pay rate feature as well. So I will say this is exactly my average underscore pay rate. This is exactly my minimum underscore pay. This is exactly my maximum underscore pay. And let me just execute this line of code. And if I'm going to say df.had, let me execute, and you will see we have 2 more new features which are exactly my average underscore experience and average underscore pay rate. Let me cross check what exactly its data type. Let me just execute this line of code. Now you will see both the set of feature belongs to my float class. Now all your data is according to what you exactly need, especially this set of 6 features, what you have featureized and what you have created, just to understand data in much more depth. So in the next session, what we will do is we will try to clean this post date feature, and we will try to featureize this post date feature, and we will try to extract some more important information. Hey, can you return me what is a day, or what is a week, or what is an hour, or all these set of features that we really need in order to understand our data pretty well. So that's all about this session. Hope you love the session very much. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session, we have basically cleaned our experience feature, as well as we have cleaned and featureized our pay rate feature as well. So in this session, our cool challenge is all about you have to perform the feature engineering on top of your post date features. Let me very first figure out where exactly we have this feature. So let me show you where we have this feature, and if I will scroll it, you will see a feature which is exactly your post date. Now what you have to do is very first you have to clean it. Along with that, you have to perform feature engineering on top of this post date feature, so that you can extract some date time format. Let's say what is a day, what is a post day, what is a post month, or what is a post year. So these are some of the things, these are some of the set of features that you can extract from post date feature itself, and you can come up with some meaningful insight from data later on. Again folks, as far as this problem statement is concerned, there are tons of ways just to solve this. So very first, let's try to discuss all the possible ways just to extract some meaningful set of features itself from this post date feature. The very first approach is you can define your own function. Again, whatever problem statement you have, this is one of the way just to solve it. If you are good with your programming, if you have good logical thinking, if you have good programming skills, just define a function completely from scratch and apply it on your data. That is one of the best way. The second way is you can think of some inbuilt functionality. Again, if you are good with data manipulation, data pre-processing, you can always think of using some inbuilt functionality, inbuilt libraries available in Python. So the second one is you can think of using our datetime module. Again, using this datetime module, we have to just write some lines of code and we are able to extract those set of features. This is our second way. The third way is these. Again, let's try to very first mention some of the optimal way just to extract features. The third way is you can think of using your lambda approach. Again, these are exactly my optimal way. The fourth one is using your map function. You can also extract your datetime features from this postdate feature. And this is, imagine this is my postdate feature. So in this session, what we will do is we will discuss this very first one approach, and we will also discuss this approach just to extract datetime features itself from this postdate feature. And these two approaches will be your assignment. You have to solve it, and at the end of every use case, you will find all the solutions of all these assignments. So in this session, we will typically touch upon the very first approach and typically, of course, on this fourth one. And these set will be your assignment. Just try to solve it. Again, if you're not able to solve it, just don't worry. Just check out the solution at the end of the use case where we have specific videos for each of the assignment that I have uploaded here. But before applying all these functions, if you will figure out this postdate feature is exactly belongs to my object category. So this is the very first pre-processing that you have to do. Very first, you have to convert it into some datetime functionality, into some datetime nature. Again, just to do this, you have multiple ways. So typically in datetime, we have basically two data type. The very first one is my datetime 64, and this is exactly ns, that stands for nanosecond. The second one is you can think of using M8ns. This is your second data type that follows whosoever feature has this category that belongs to my datetime functionality. Again, both are similar. This is exactly my general data type, while this one is exactly my specific data type. Both are similar. It entirely depends upon how your NumPy library is compiled. So very first, let me show you all these stuffs. So if I'm going to say numpy.dtype, and very first we have to mention our data type is exactly, let's say, datetime 64, and here we have to mention this ns, which stands for nanosecond. And I'm going to say equals to numpy.dtype. The second one that we have to mention over here is exactly my M8. I'm going to say this is exactly my M8, and over here we have to mention our ns, which stands for nanosecond. And I will say I have to append this one as well. Let me just execute this line of code. Now you will see it will return us true. It means both the data type are exactly similar. It entirely depends upon how your NumPy library is exactly compiled. Now what we have to do is, very first we have to convert its data type from object to something known as datetime. So what I will do is, very first I'm just going to say, very first we have to access this feature. So if I will say df of pay rate, and on top of this, if I will call, let's say, dtype, just to show you, you will see it belongs to object data type. Now what we have to do is, let's say I will just define a function. Let's say function name is, let's say, function1. Let's say this is exactly my function name. And what this function will do for us, it will say whatever feature I will pass to this function, it will extract something known as day, it will extract something known as month, along with it will extend year itself from this feature. So what I will do is, imagine we have some rows that will throw some kind of error for us, or that will throw some kind of exception for us. So again, we can handle such kind of exception using try except block. That's a way how we can handle our exception. So I will say whatever code I have written over here, in case if this block of code will give any kind of error, just add your except block, and then inside that except block you can just print something else. That's what this function will do for us. So I'm going to define a function. Imagine fetch, let's say fetch underscore dt underscore attribute, and over there whatever data frame I will pass, and of course whatever feature I will pass to this function, it will exactly return us a set of features or set of datetime features. So very first we have to return something else. So what we have to return? So very first we have to access that feature. So I'm going to say data frame of exactly feature. On top of this, just to return date, I will say .dt.day. And of course, just to return your something known as year, you have to just call on year, and just to return something known as month, you have to just call .month, and to return year, you have to just call something known as year. Now what I will do is I will say once I call this function, I have to return values exactly in the form of data frame or in the form of series data structure. So on top of this, why not just create its series? So I will say, hey, just create its series. So I will say this is exactly data in the form of list. Now I will just enclose it. Imagine this block of code will return some kind of error. So what I will do is I will say, why not just add your exception handling over there? So I will say just add try block. Very first you have to maintain your proper indentation. Now once you have your indentation, then I'm going to say I have to add my except block. Inside that I will say I can print something else. What you can do, I'm going to say, let's say data type, let's say this is exactly data type is not supported. Whatever you want to print, you can print it as well. It's all up to you. So let me just execute this line of code. So if I'm going to call this function, which is exactly fetch underscore dt underscore attribute, over there I have to just pass my df and my feature, which is exactly post date. Let me just execute this line of code. Now you will see it will exactly return me as data type is not supported, because right now it supports my object category. Now what we have to do, we have to very first convert this from object category to something known as datetime 64, or you can also think of converting this into emit. Both are similar. That's entirely depends upon how exactly your numpy is compiled. Now what I will do is very first I have to convert its data type. For this we have an inbuilt function which is exactly pd. Over here we have a function which is to underscore datetime. Over there I'm just going to say I have to just convert this. Now I will say I have to also update this as well. So I will say let me just execute this line of code, and if I'm going to say on top of this, if I will call dtype again, now you will figure out you are getting a parser error. Now you will see you have an unknown string format and blah 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 blah. Again, now you can check we have passed a wrong feature. My feature was exactly post date, and unfortunately we have passed this pay rate. That's why we are getting this error. Now what we will do is we will just modify it, and we will also modify this one as well. And now what I will do is I will again execute this line of code. Now you will see all your stuff gets okay. Now what I will do is I will say, hey, can you return what exactly is data type? Let me again execute this line of code. Now you will see it belongs to something known as datetime 64 format. It means now it belongs to my timestamp nature or datetime format. Now I will say I will just call this function what I have written over here. I will say let me just call this function, and you will see these are all the values that it will return us. So what I will do is I will say, can you store all these values? So what I will do is I will very first define 3 features just to store this. The very first is exactly your day. The second is exactly your nothing but my month. So I will say this is my month. The third is exactly your year. So I will say this is exactly my year. Let me just execute this line of code. And if I'm going to say df.head, and if I will execute this line of code, now you will see you have 3 new features inserted in your df data frame, which are as follows: as day, month and year. And these are features that you have extracted itself from your post date feature. So this is typically my first way. The second way is you can think of using your map approach. Let's try to implement using your map approach as well. So what, in a nutshell, what this map will do, it will typically says whatever function you have, just apply this function on top of each and every row of whatever sequence you have or whatever data you have. So what I will do is, I will say, very first you have to define that function that you have to apply on top of this sequence. So very first you have to define some function for this. Again, this map will exactly return some kind of iterator. So on top of this iterator, I can either call list. Again, in Python 2, it typically returns tuple, but in Python 3, it typically returns our iterator. That's a very basic difference between our Python 2 and Python 3 with respect to this map function. So I'm going to say, very first we have to define that function. Imagine fetch underscore dt underscore attribute, let's say 2. Let's say this time this function is, let's say 2. So whatever x I will pass to it, what it will do, it will say just return something else. Let's say x dot day, which returns exactly my day, then x dot month exactly, then I will say x dot exactly my year. Then what I will do is, I will say just enclose all these things in list, and I will say just return it. So I have to use just return keyword, that's it. Now what I will do is, I will say, let me just execute this line of code. Now what we have to do, we have to just call this map. I will say, I have to just call this function, which is exactly this attribute 2. Now we have to apply this function on top of our post date feature. This is exactly that feature. And if I will execute this line of code, it will exactly return me some iterator at this particular address. Now what I will do is, I will say, hey, on top of this, I can just call some data structure. Let's say data frame. I will say, I am just going to call my data frame data structure, and I will store all the values inside my data frame. Let me again execute this line of code. Now you will get all these values. Again, you can just manipulate this data frame just using some basic function. So I will say dot rename. On top of this, I will say I have to rename exactly my columns, and over there I have to mention data in the form of dictionary or in the form of key value pairs. I will say just replace or just rename 0 with something known as day. I will say just rename it with day. Then I will say just rename your month exactly with your month. Just rename 1 exactly with your month. Then I will say just rename your 2 exactly with your year. I will say just rename all these stuffs. Now after renaming, I will say, why not store it somewhere else? I will say fe underscore date and let me execute it. And if I'm going to say fe underscore date, let me just execute. You will see this is exactly the data frame what we really need. Now what we can do is, we can just concatenate this data into my df data frame. So for this, I will say pd.concatenate, and over there I have to mention very first what is my actual data, which is my df, and what is exactly my fe underscore date. Now I have to mention my x is equals to 1 as well. Let me just execute. Now you will see you have 3 features again. You can see day, month and year. So these are those set of features that you have extracted by defining function and applying function. And these are those set of features that you have achieved using your something known as map, which is an inbuilt function. So these are basically 2 approaches. Other than 2 approaches, we have tons of ways just to solve this similar problem statement, just to featureize this post date feature. One of the way is date time and one of the way is lambda. So these 2 ways will be your assignment, and you will get the solution of these 2 ways at the end of this use case. Again, if you have any issues, any doubts regarding these 2 ways or any other thing, feel free to drop a query in the Q&A of the course. So that's all about this session. Hope you love the session very much. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session, what we have done basically is we have cleaned this post date feature, or you can say we have pre-processed it, as well as we have featureized this post date feature by just defining some lines of code, including exceptional handling. That's what we have done, especially in the previous session. So in this session, what we have to do is we have to clean exactly my job underscore location feature. Again, let me show you where exactly we have that feature. So if I will say df dot columns, let me execute. Now you will see we have a feature which is exactly job location underscore address. Let me very first access that feature. If I will say, let me very first access it, you will see you have all the values in job location address as Chennai, Bangalore, Gurgaon, Delhi, NCR. These are metropolitan cities of India. Now what I will do is, I will say, very first we have to access it, and on top of this, if I will call, hey, can you return what exactly is the frequency distributions for this, I will just call this value counts on top of this. And if I will execute this line of code, it will exactly return me this messy stats. So what I will do is I will say I just need some top 10 features or top 10 cities. For this I will just call dot head of 10. And again, if I will execute, these are my top 10 cities in terms of job location. These are exactly my Bangalore, Mumbai. Again, you will see we have this Bangalore, and again we have this Bangalore. So these features or these subcategory exactly need some kind of cleaning so that we do not have any kind of repetitions as a subcategory, as a similar subcategory. Similarly, you will see we have Hyderabad, and similarly we have again Hyderabad as a new subcategory. That's what we have to do, especially in this session. We have to clean this job location underscore address feature just to ensure that we do not have any repetitions inside this job location feature. That's what we have to do. Now, very first, let's create the copy of data frame so that whatever manipulation you will do on top of that data. So I will say data is equals to df.copy. Let me very first create its copy. Let me execute this line of code. Now what I will do is I can find some unique values or all the unique categories inside this job location and underscore address feature so that we are able to address out all the duplicate subcategories inside this feature. So I will say basically data of job location address. On top of this, we're going to just call something known as unique. Let me execute this line of code. So these are all the unique values. Again, you will figure out inside this, of course, this is dot dot, that includes lots of unique subcategories inside a job location feature. So to make it more readable, you can just convert it into series data structure, or you can convert this into something known as data frame. It's all up to you. Let me convert this into series. So what I will do is I will say, let me execute this line of code. You will see we have Chennai, we have Bangalore, we have Mumbai, Bangalore, Calcutta, Chennai, Coimbatore, and we have tons of cities and all these observations over here. So things are not more user friendly over here. So what you can do is you can find, let's say, top 60 cities that have more number of job location, of course, as a more number of job location address. So what I will do is I can just copy these lines of code, and over there I can just paste it here. I will say this is exactly, let's say, data, and let me pass some values, let's say 60. Let me execute this line of code. These are all the stats. Now I will say just access index. Now let me execute. These are all these cities or all these subcategories that have maximum number of job locations. Now from this you will figure out we have some set of features that are, we have some set of subcategories that are duplicate. Over here you will see we have Hyderabad and Secunderabad and we have Hyderabad over here. Similarly, we have Bangalore, Bangalore, and we have this Bangalore and Bangalore, and we have Bangalore as well. Similarly, as Bangalore and Bangalore, similarly we have lots of other subcategories that gets started itself from Bangalore. Like we have Bangalore, Bangalore. Again, in such type of scenarios, we typically need some kind of replacement. So what type of replacement you can say? You can say, I can hold all this replacement exactly in the form of dictionary, where I have some key and where I have some values. Imagine my very first replacement is, let's say, I will say, just replace it, let's say, just replace it with Bangalore. So I will say just replace it with Bangalore. So this is exactly my key and this is exactly my value. I can just call some functions and I will say wherever wherever this row is available, just replace it with Bangalore. Similarly for this one as well. Similarly, for all the rows, wherever we have such combination is available, we will say just replace it with Bangalore. Again, fortunately, we have a CSV file that we have over here, where we have all the possible replacements. So what we will do is we will load that file. And we will convert that file into something known as dictionary, and we will apply this dictionary on top of our job location address feature just to remove all these duplicate subcategories. That's what we will do. So you will see this is exactly my data set, which is my replacement, or this is my replacement CSV file that has all the pairs, all the possible pairs to which you can replace all your values. Let me very first copy this path, and I'm going to say, very first you have to read it. So I'm going to say pd.read_csv. Over there, I'm going to say this is exactly my path, and over here my file was exactly replacements. Let me very first cross check what exactly it's for name. Yeah, this is my replacements. I will say this is exactly replacements.csv. Now what I will do is I will just execute this line of code. You will see it will return all these stuffs. Now what I will do is I will say I have to just convert this data frame into something known as dictionary. So what I will do is I will say I will just make this feature as my index. So for this I have to just call something known as set_index, and on top of this I will say just make this feature as your index. That's it. Let me execute this line of code, and this is your amazing data frame that you exactly need. Now let's store this data frame somewhere else. So what I will do is I will say, let me store this in, let's say, reputation or replacement. I will execute this line of code, and let me just print this data frame, which is exactly my replacement. Now what I will do is I will just convert this into dictionary. So I will say replacement.to_dictionary. You have this inbuilt, fortunately you have this inbuilt function just to convert all your set of values into dictionary, where this will become my key and this will become exactly my value. Let's say we have Delhi, NCR, National Capital Region. These are all the boundary regions of Delhi, which is exactly a capital of India. So let me again execute this line of code. This is exactly a dictionary. So let me very first store this dictionary somewhere else. So I'm going to say replacement underscore, let's say dict. Let me execute this line of code. Now what I will do is I will say on top of data, I will just call something else, which is my replace function. I will say I will just very first say just call this replace underscore dict, and I will say whatever pairs it have, just replace or just perform all these pairs inside my data. That's what my replace will do. Once I will do it, I will say I have to update my data frame as well. So for this I have to use this in place parameter. Apart from this, I have to say I have to use all the regular expression whatever we have over here. So for this we have to use this regular expression parameter, and I have to assign it as true. Now let me just execute this line of code, and if I'm going to say data of job underscore location, and this is exactly my address feature. On top of this, if I will call, let's say, something known as value counts, just to obtain what exactly it's frequency distribution. Let me just execute this line of code. Now you will see initially, let me show you that. Yeah. This is your initial count. Let me just copy it and let me just paste over there. I will say let me just paste over there. You will see initially with respect to Bangalore, you have count appropriate as 3700, or you can say approx 4k. But after doing all these manipulations on top of your job location address feature, now your total job count is more than 5k. Just on account of you have done lots of manipulation that you exactly need. So that's all about this session. In the upcoming session, what we will do is we have successfully cleaned this data. So we will try to store this. We will try to store this data, which is exactly data frame, or we will try to convert this data frame into some CSV data, or we're going to store it in some databases as well. So in the upcoming session, what we will do is we will try to store this data somewhere else, and then we will gradually move ahead with our analysis, whatever problem statement, whatever real world challenges, whatever cool challenges we have. That's what we have to do, especially in all our upcoming sessions. So that's all about this session. Hope you love this session very much. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session, we have basically cleaned this job location underscore address feature so that we do not have any duplicate subcategories inside this job location underscore address feature. That's what we have done basically in the previous session. So in this session, what we will do is we will try to find out some separate data for some particular city. Let's say with respect to Delhi, or let's say with respect to Noida. Again, Noida is just a neighboring region of this Delhi city, which is the capital of India. So just to show you whether things have manipulated or not, again in DF we have that data where we have all the duplicate values. Inside data, which is one of my data frame, we have all these values where we do not have, or we can say where we have less duplicate values. Again, inside this replacement underscore dictionary, we have all the possible pairs where my duplicate values can be occurred. We do not have all these pairs, we have only the possible pairs. So what we'll do is we will try to find separate data frame, let's say for Noida, or let's say for Delhi. Again, just to find separate data frame for any particular city, you have multiple approaches just to solve this problem statement. Again, the very first one is you can create your own function, or you can use a concept known as filter, where I will apply a filter and I will say wherever my job location is Noida, just extract those rows or just filter out those rows and just return as a data frame. This is my very first approach. The second approach that you can think of using your query, you can run some query and you will see just return those rows where my job location is Noida. This is your second way. Again, if you are extremely good with data manipulation libraries, let's say with pandas or numpy, these things will be a piece of cake for you. The third way is you can think of using some inbuilt function using isn, which is an inbuilt function of pandas. In a similar way, this query is also an inbuilt function of pandas. Again, pandas is extensively used module in case of data cleaning, in case of data wrangling, in case of data manipulation. So if you have good command on pandas, these things will be just piece of cake for you. So we will try to solve this problem statement using the very first approach, which is basically my filter approach, and these two will be exactly your assignment. So just try to solve it. Again, we will just try to solve the similar statement from multiple perspectives, just to improve your programming skills, just to improve your logical thinking. Again, in real world, your problem solving skills is a primarily skill that you exactly need. That's why we will primarily focus just not on the problem statement, as well as we will primarily focus on all the ways how to tackle the problem from broad perspective. That's why we will try to solve the similar problem statement from multiple ways. So these will be your assignment. Just try to solve it and you will get your solution at the end of this use case. So I'm going to say, very first I have to add some filter. So I will say this address equals to basically my Noida. So I will say this is my filter. Let me store it in, let's say in filter. So I will say this is exactly my filter. Now what I will do is I will apply this filter on top of my DF data frame. So I will say, let me just apply this filter on top of my DF data frame. And if I will execute this line of code, you will get all the rows where my job location is all about only Noida. So what I will do is I will store, let's say I will store this somewhere else. Let's say P, whatever name you want to send, or you can say loc underscore Noida or location underscore Noida. Let me just execute this line of code. Now I'm just going to print this data frame, which is exactly location underscore Noida. Let me just execute this line of code. Now in this data frame, you will figure out you have all these rows where my job location is Noida. So yeah, let's say we have this index where we have Noida as a job location. So I will say df of let's say job location underscore address. You have to just access this feature, and I will say I need data of let's say this index. Let me just execute this line of code. You will get your Noida. But if you will execute this line of code with respect to your data, which is my data frame, and if I will execute it, now you will see Now you have Delhi. Now you will thinking why? What's the magic here? Because you have already manipulated it using this dictionary. What you have achieved by converting this data frame, which is your wrap, into dictionary by just calling inbuilt function, and you will end up having your dictionary. Then you will just replace this dictionary using a replace function, and you will end up having your manipulated data. That's what I really need to show you. Now let's try to figure out what are the total subcategories before manipulation and after manipulation. So what I will do is, I will say on top of this job location address feature, I will just call something known as value underscore count, or there is one more alternative. Let me show you that. And on top of this, if I will call, let's say dot index, and let me execute, these are all these different locations. On top of this, I will say just compute the length of this list. Let me execute. You will see before manipulation you have 2329 total unique subcategories inside your job location address feature. There is one more way. On top of this, if I will call n unique this time, and this time I have my data as my data frame, and if I will execute, this time you have just 2141 total subcategories. It means there are approx more than 180 subcategories that contains some kind of duplicacy, and that you have removed what we have shown you just a while ago. Of course, using this replace and just passing all these custom parameters over there. That's what we have done, especially in the previous session. So if I'm going to say data of head of, let's say 5, now you will figure out you have all these columns and all these observations over here. And on top of this, if I'm going to say data dot columns, let me just execute this line of code. Now from all these columns, if you will figure out, you have some unnecessary column. Of course, my experience column, because from this experience you have already fetched your maximum experience and your minimum experience. It means this experience makes no sense in this data frame. Now you have to remove it or you have to drop it. Similarly, you have dropped some more number of features, which are my post date as well as my pay rate feature as well. It means you have to eliminate exactly your experience feature, your pay rate feature. You can also remove this unique ID because it makes no sense. In addition to that, you can also remove your post date feature. So what I will do is, again, you have to write 4 lines of code. So instead of writing 4 lines of code just to remove all these features, why not just define a function for this? So what I will do is, I will say define a function, let's say drop underscore, let's say feature. Over there, whatever column I will pass to it, it will just drop this column. That's what this function will do. I will say data dot drop, and over here I will just pass some column, and I will say x is equals to 1 because I have to drop it in a vertical fashion. Then I will say in place parameter is exactly my true because we have to update my data frame as well. Now let me just execute this line of code, and I'm going to say drop underscore feature. This time I have to call this function especially for my pay rate. So I will say this is my pay rate. Let me execute this line of code, and again let me again call this function. This time it is exactly my experience feature. So I will say this time it will be for experience feature. Now again call this function. This time this function will be for, let's say post date feature. I will say this is my post date feature. Let's again call this function. Let's say this time I have to pass one more feature, which is unique underscore ID. That makes no sense in my analysis. So why not just remove it? Now let me just execute this line of code. And if I'm going to say data dot columns, now you will see you do not have any column as pay rate, experience, post date, unique ID in your data frame. Now if I'm going to say data dot head, and let me pass some value, let's say 3. These are the first 3 observations of my data frame. Now you do not have any feature as pay rate, experience, unique ID and all these stuffs. So these are exactly my featureized feature that we have extracted from pay rate, from experience, and of course from my post date feature. That's what we have done till now. Now let's try to load this data, or let's try to save this data somewhere else so that After it, we can continue with this data and we can perform with our analysis. So what I will do is I will say just convert this data frame into some CSV, or you can also think of converting this data frame into some databases. It's all up to you. It's entirely depends upon your company. It entirely depends upon your use case as well. So what I will do is I will say I have to store this data frame, or I have to store this data somewhere else, let's say as this path, and let's say my let's say data set name will be, let's say, Naukri underscore data dot CSV, and I will just append R, that stands for raw string, and I will say just assign index as false, so that it will not hold all these indexes what you have over here. Now what I will do is I will just execute this line of code, and you will end up having your data set as Naukri underscore data in the form of comma separated value, or in the form of CSV. You can often term it as CSV. So that's all about this session. In the upcoming session, what we will do is we will try to perform some descriptive analysis along with correlation, univariate analysis, bivariate, tons of analysis we have to perform on top of this data, which is exactly my Naukri underscore data. So that's all about this session, and if you guys have any query regarding this session, feel free to ask us in the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, till now what we have done is we have cleaned our data. Again, in the real world you will always get your raw data. So the data that we have was exactly in the form of raw format. So very first we have performed data cleaning just to clean it, as well as we will perform feature engineering or featureization just to come up with some set of features that helps us a lot at the time of analysis. So once we will clean and featureize it, what we have done, especially in the previous session, is we have stored this data, especially in the form of CSV format. Just to make things simple, we have stored it in the CSV format, and we have this data. Now what we have to do is this is exactly my clean data. This is exactly my clean data. Now this is my clean data. Now we have to we have to load this data. Once we will load this data, then we will perform lots of analysis, and we will try to solve lots of real world challenges that we face in real time environment. So very first I am just going to import some basic module. The very first is exactly my NumPy. I am going to say let me create an alias, let's say NP. The second one is you can think of importing your pandas, that is extensively used for your data manipulation along with your data cleaning as well. Then I'm going to say I have to import my matplotlib.python plot just for data visualization, just for basic data visualization. Then I'm going to import some advanced, or you can some good visualization module as cborn. And you can import some warnings module just to get rid of all the warnings that will come across your cell. So I will say import warnings module. Then inside this warnings module, I have some module which is exactly I think filter underscore warning. Over here, if I will press, let's say if I will press tab, yeah, this is exactly the module. And over here I will say whenever a warning will come, just ignore it. Let me just execute this line of code. So using this PD, I have to just call a function which is exactly read underscore CSV. Over there I have to just paste some path from where we have to read this data. Again, we have this data set which is exactly my clean data. Now what we have to do is very first we have to read this data which is my Naukri underscore data dot CSV, and let me append R, that stands for raw string, just to make things simple, as this is my path and this is exactly my file that we have to read. Now it will exactly return me some data frame. Let me store, let's say, in df. So df is exactly a data frame object. Now let me just execute this line of code, and now I'm going to say df dot, let's say, head, and let me just showcase, let's say, first 4 values. Let me execute this line of code. So this is exactly data frame on which you have to work, on which you have to come up with some meaningful insights. That's what we have to do in a nutshell. So the very first problem statement is all about you have to perform something known as descriptive statistics on top of your data. Again, just to perform descriptive statistics, you have some amazing function that you can think of on your data. So what I will do is I will say df dot describe, just to describe my data, or just to perform some descriptive stats. Let me execute. Now you will see with respect to each and every feature you have some count, mean, standard deviation, some minimum value, and these are nothing but my 5-point summary. Or I will say, let me just transpose this matrix or transpose this data frame. I will say just call .t on top of this. Now you will see, with respect to each and every feature, I have some count, I have some mean value, I have some standard deviation, I have some minimum value, I have some 25th percentile data, that is exactly my lower quartile. This is my median, this is my 75th percentile data, and this is exactly my maximum value. Again, in statistics, it is often known as something known as 5-point summary. It is known as 5-point summary of my data. So let's understand all these terminologies in much more detail, or let's understand all these terms in a very layman way. Imagine I have some, let's say, set of values, let's say 0, let's say 1, let's say 2, let's say 3, let's say 4, let's say 5, let's say 6, let's say 7, 8, 9, let's say these are my set of values. So from this data that we have, this is exactly my minimum value, this is exactly my maximum value. Now we have to find out some 25th percentile data, we have to find out some 75th percentile data, and we have to find out some 50th percentile data. That is exactly my median. Median is nothing but my middle value. So from this set of values, this 1 is exactly my 10th percentile data. This 2 is exactly my 20th percentile data, which basically says there are total 10% data point that are below than this value. That is the exact meaning of this 10 percentile data. Similarly, this 20th percentile data basically means there are total 20% total data points that are my 0 and 1 that are below than this value. That is the exact meaning of 20th percentile data. In a similar way, this 25th percentile data says, below than this threshold or below than this value, we have around 25% total data points that are below than this value, or you can say there are 75% of data points that are greater than this value. That is the exact meaning of this 25th percentile data. In a similar way, 50th percentile is exactly a middle value. It means over here we have equal number of observations, over here we have equal number of observations. It means this is my x and this is also my x. In nutshell, this is a very layman explanation of my median. Similarly, 75th percentile data says from this value we have just total 25% data point that are greater than this value, whereas there are 75% data point that are below than this value, and this is exactly my minimum value. This is all about my 5-point summary in statistics. Again, this is the statistics with respect to your numerical features. Let's try to find some summary of your data with respect to your categorical features. So what I will do is, I will say over here we have some inbuilt custom parameter. Let me very first cross check. We have a parameter which is include. Let me go through its documentation. Over here, if you will see include, you will see that, let me show you that by default value of include is exactly none. You will see, let me show you that. By default it is none. It means it will include all the numerical columns. Again, just to include all the categorical features, what you have to do basically is you have to use something known as, you can mention something like this, where you can say include all those features where we have a data type as object. And that is a simple explanation of what the code is written over here. So what I will do is I will just paste all the code according to the documentation that I have shown you just a while ago. Let me execute this line of code. Now you will see you have all these stats. Now on top of this, I will just transpose it, and this is the amazing thing that you have over here. Now you will see with respect to company, you have that much total number of observations. With respect to education, you have total number of that much education, or total number of, with respect to education, you have total count is that much. industry count is that much. These are nothing but my total observations in each and every feature. Again, with respect to company, there are total that much unique number of company, almost close to 8k, almost close to 8k. With respect to education, we have around close to 24 entries or unique entries. We have unique industries at 63. Job description which are unique are nothing but my approx close to 21k. 2k are nothing but job location address. Job title are unique which are approx close to 17k. And site name is just 1, and we have total unique skills as 45. And these are nothing but my top values, and these are nothing but that frequency of that top value. This is typically my statistics with respect to my all the categorical features what we have achieved just using this parameter inside my describe inbuilt function of pandas. That's what I have shown you. So in the upcoming session, what we'll do is we will try to analyze data, of course, using something known as univariate analysis, something known as bivariate, something known as multivariate. Again, those of you who do not know what is univariate, what is bivariate, what is multivariate, we will discuss it in much more detail using the real world examples or using the data that we have. So that's all about this session. Hope you love the session very much. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session what we have done is we have performed something known as some descriptive analysis on data just to understand some behavior of data. Now what we have to do is we have to perform lots of analysis including basic plus some advanced analysis. So whatever analysis we will perform on top of this data, that will exactly a part of 3 types of analysis. So let me just write down as my analysis will be categorized into 3 categories. Typically it will categorize into 3 categories. The very first one is you can think of something known as univariate analysis. The second one is you can think of something known as bivariate analysis, and the third one is you can think of something known as multivariate analysis. Again, just to get a high level overview of all these analysis, univariate analysis is that type of analysis where typically my one feature is involved itself in that analysis. Bivariate is that, bi means 2. It means where we have 2 features are involved in that analysis, and in multivariate analysis we have more than 2 features itself in this multivariate analysis. That's a very high level overview of all these types of analysis. So let's understand much more all these types of analysis from real world perspective. So the very first one is exactly your univariate analysis. So let's try to understand all things, or let's try to understand from real world perspective. So from real world, you can think of univariate analysis as, hey, let's say what is the type of available data? What is the type of available data? Or let's say what is the distribution? What is the distribution of data looks correct or not? This is one of the univariate analysis. The third univariate analysis can be, hey, is there any anomalies in data or not? Again, this is, or you can say if we have any outliers in data or not. This is one of the univariate analysis, because in this analysis typically my one feature is involved. Typically, again, you can perform this anomaly analysis or outlier analysis using 2 features or multiple features as well, but typically it is exactly comes under my univariate analysis. So univariate analysis can be done both on our continuous or on numerical data, and it can be done also on something known as categorical data. Again, categorical data is that type of data which have basically some subcategories or has some categories, and continuous data that whose data point are exactly continuous in nature, like weight of a person or height of a person or amount of sugar that you have. These are exactly my continuous data. And categories is like we have some country feature, like we have some strength feature. So these are all about my categorical data. So for continuous feature, we can think of using something known as box plot, because box plot is extensively used just to detect outlier. just to find 5-point summary of data. So typically it is used for one feature. That's why it is a part of univariate analysis. Again, box plot is also used for two features, for bivariate as well as for sometimes for your multivariate as well. But typically it can be used for my univariate analysis. The second thing you can notice is exactly my histogram. You can often use histogram for your univariate analysis. Similarly, your density curve, or you can say as my distribution plot. You can say as my distribution plot. Again, these are all the ways that lies under my graphical analysis. So to perform univariate analysis, we have basically two types. The very first one is your graphical analysis. The second one is exactly your tabular analysis. So inside this tabular analysis, we can call some inbuilt function like describe function, and we will end up having some kind of table from which we can extract some meaningful insights. That is exactly my tabular analysis. This is my graphical analysis, in which we will end up having our final graphs that will give us some meaningful insights so that we can represent to it our stakeholders. So in context of categorical features, you can think of using some frequency distribution. And again, you can achieve this frequency distribution by just calling a value count function that we have extensively used throughout our all the case studies. That is exactly my frequency, or you can say frequency distribution. Again, you can also think of using your bar chart, because bar chart is nothing but you have some category and you have some count. Again, that is also my univariate analysis for my categorical feature. In a similar way, we have also my pie chart. In a similar way, we have also my something known as count plot, which is of course a part of my Seaborn module. So these are typically my 4 ways just to perform this univariate analysis for categorical features. Again, let's understand from the real world perspective how you can perform this univariate analysis in the real world scenarios. So from real world scenario, we can have a problem as, hey, can you find what is the distribution of, let's say with respect to this data, hey, can you find the distribution of your maximum pay feature? Or can you find what is the frequency distribution of your company feature? These are some of the univariate analysis with respect to this data or with respect to real world scenarios. These are typically my univariate analysis. So now let's try to understand what exactly is my bivariate analysis. Again, bivariate, in which we have two features. Imagine we have two features as, let's say, x and y. And what this bivariate analysis will say, it says it is performed just to find if there any relationship exists between x feature or between y feature or not. So in bivariate, we can have 3 scenarios. The very first scenario is my x feature can belongs to my categorical nature, and my y feature can belong to numerical format. This is my very first scenario. The second scenario can be, let's say, my x also belongs to numerical format and y also belongs to numerical format. The third scenario will be, again, this is a very rare scenario that hardly happens. The third will be, let's say, my x is also categorical nature and my y is also, or my y also follows a categorical nature. So typically there are 3 scenarios itself in this bivariate analysis. So if we have such scenario, we can think of using some chart, let's say some pie chart, some donut chart. Again, donut chart is nothing but it is just an extension of my pie chart, having some hole like parameter in donut chart. In a similar way, you can also think of using bubble chart. In a similar way, you can also think of using some tree map. So these are all the visualizations that you can think of if you have this first scenario. The second scenario where both the features follow numerical nature. So in such scenario, you can think of using your correlation approach. Similarly, you can find, hey, if there any relationship exists or not. In such case, you can use this scatter plot. Similarly, you can also perform something known as regression analysis. Again, just to perform this regression analysis, we have an assumption that there is certain kind of correlation already available between two features. Similarly, for third case, with respect to, let's say, with respect to this data, what we have in this use case, it is very hard to just find out this third case. So let's try to find out this third case in very, let's say, in some toy data. So of course, if you have heard about something known as Titanic scenario, over there you can think of a scene. Let's say, does gender feature affect on survival rate or not? So this is typically your bivariate analysis that comes under this third category. And of course, in such scenarios, it is always good to have that in one of the features we may have some boolean values, because survival rate, if it is 0, it means that person is no more survived. If it is 1, it means that is survived on the Titanic ship. Again, Titanic is a tragedy if you haven't heard about it. So for such a type of scenarios, we can think of using something known as chi-square test, which is exactly my statistical test. And this is one of the rare scenarios that you will face even in the real world. Typically, you will face this second scenario and this first scenario. So let's try to find the real world problems that you may face in this data. And the data set is all about my Naukri underscore data. So let's try to find out how you can perform the bivariate analysis from this first scenario and from this second scenario as well. So the problem statement that you may encounter in the real world with respect to bivariate analysis, let's say, hey, can you return me what is the minimum experience, let's say for different companies. Let's say, hey, can you return me what is the minimum experience for different companies, or can you return me the minimum experience with respect to, let's say, different industries. Just to get job in different industries, hey, can you return what is the minimum experience that you need in order to get a good job or in order to get a good post in different kinds of industry. These industries can be IT industry, manufacturing industry, marketing industry, and all these types of industry. So these are some real world problems that you may encounter, of course, in real time environment. So with respect to this second scenario, we have two cases. Typically, we have three cases. Again, regression is nothing but, it is just you can say it is just a better format or a extension of, you can say, correlation, just to visualize data in a much more better format. Again, correlation is all about how strongly, let's say, you have to find correlation between, let's say, X and Y. That typically says how strongly my X and Y are correlated with each other. Imagine its value as, let's say, 0.9. So it means we have a very higher correlation. Again, if we have a correlation value close to 0, it means we have very low correlation. And if we have more, the value will be close to 1, we have a higher value of correlation. Similarly, this scatter plot between X and Y, where my X and Y must be of numerical nature. That simply says, hey, what is the relationship between X and Y? Whether they are linearly related, or whether they are non-linearly related, or whether they are unrelated, or whether they have some complex relationship. That's a very layman explanation of if you are going to think for a scatter plot between two features, of course, those two features must follow this numerical nature. The third is exactly my regression approach. Regression approach is all about where you have to predict, let's say, where you have to predict Y, of course, from X. That is typically your regression analysis. So in the real world, how you can think as, hey, can you find out the regression analysis between my minimum experience feature and maximum experience feature, or can you find the relationship between minimum experience feature as if minimum experience increases, or can you find a relationship between maximum experience and Of course, my salary. It means if maximum experience increases, whether my salary increases or not. That's a very layman explanation of what is happening behind the scene. Again, the topics that I have covered over here, that is enough in order to crack all the data science interviews. Of course, over here, in order to crack all the data science, including all the data analyst interviews. These topics are typically designed just to keep in mind the interviews of data science and data analyst, especially over here. Here, let's say I have talked about all the different types of analysis. So we have discussed primarily just 3 types of analysis: univariate, bivariate, and of course my multivariate. Multivariate is all about where we have, let's say, 3 features, where typically my 3 features are involved. Again, with respect to multivariate analysis, you can think of a real world problem as, hey, can you find the distribution of, let's say, minimum pay, where my skill must be from IT, and let's say my location must be of Hyderabad. Just to understand the problem statement is one of the key skills that you really need in order to crack the data science and data analyst interviews. So these type of real world problems that you might encounter with respect to my multivariate analysis. Again, we have especially designed this course keeping data science and data analyst interviews in mind. Even for a data scientist, your bunch of time you will spend itself on this data analysis. So in this entire course, we will primarily focus on the problem solving. So that it will improve not your programming as well as your logical thinking. As well as we will focus primarily on all the life cycle of data analyst project or data analysis project. We will primarily focus on these 2 things, how to do all these things. Inside this life cycle, there are lots of steps just to clean data, manipulate, and all these things. Along with that, whatever statistics you need in order to crack a data analyst interview, we will also touch upon that. Again, you cannot be a master at statistics until and unless you are learning it from decade, because statistics itself is a very vast topic. You cannot just cover in a couple of months or in a couple of days. So that's all about this session, and if you guys have any queries, any doubts, feel free to ask us in the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session, we have basically learned what exactly is a univariate analysis, what is a bivariate analysis, along with what is a multivariate analysis. And we have also touched upon all these various topics in context of real world. That's what we have done, especially in the previous session. So in this session, what we have to do is, again, just to perform this bivariate analysis, whether multivariate analysis, whether univariate, very first you have to come across all the columns or all the features in your data frame, whether they are numerical in nature or whether they are categorical in nature. So anyhow, we have to come up with this solution or this conclusion. Whosoever feature we have, let's say we have feature as, job title. So very first we have to select whether this is categorical in nature or whether this is numerical in nature. Again, just to do this, we have plenty of approach. We have tons of ways just to find whether it is categorical in nature or whether it is numerical in nature. So in this session, your challenge is all about, very first you have to find some features. Let's say we have to find some, categorical features. Again, just to perform this bivariate analysis, bivariate typically means we have a set of 2 features. Typically 2 features where one can be my numerical and one can be my categorical, or both can be my numerical or both can be my categorical. Again, this is a very rare case where both features can be categorical. So typically we have 3 cases and we have to consider these 3 cases just to understand our data pretty well. So anyhow, we have to find those features which are categorical in nature, and we have to find those features as well which are numerical in nature. So let's try to find, and let me note down all the ways how to find all the features those are categorical in nature, and how to find all those features which are numerical in nature. So the very first way you can think of using your own logic, you can think of using list comprehension. Just again, list comprehension is all about just to extend the functionality of list by reducing the lines of a code in list, or just to obtain the optimal code. This is one of the fancy way just to write the code. The second way is you can think of using some dictionary. Again, there are tons of ways just to find, hey, can you tell me what are all the categorical features in data? Again, just to do this, there are tons of ways available. The third way you can think as, you can apply some filter, along with you can use some enumeration in Python. This is one of the good ways just to find what all are my categorical features, or what all are my numerical features. Along with, we have some inbuilt functions in pandas. Again, if you are good with pandas, if you are good with data manipulation, finding categorical features is a piece of cake for you. So in this session, we will try to find all these categorical features using a concept often known as list comprehension, or you can also think of using list. Again, except the list comprehension, you have tons of ways just to do. You have tons of ways. So I will extremely suggest you to solve all the ways, and I will give you all these ways just as an assignment or as a practice problem. And again, if you are not able to solve, don't worry. We will provide you solution at the end of this case study where you are able to find out how to extract all the categorical features from data frame using all the ways. So the very first way is you can think of using list comprehension. So inside this list comprehension, what I will say is, imagine inside a list, I have all the features of a data frame. So on top of this list, I will just iterate it using for loop. Then I will add a condition if its data type, or if d type of a feature, let's say this is my feature, is object. If its data type is object, then just consider this feature. This is one way of when using your for loop along with list. And just to write these similar blocks of code using list comprehension, I will say, very first I will have some, let's say this is a code, let's say for my for block. Then I will add a if condition in a same line of code. Then I have some if condition. Then whosoever feature will follow this if condition, then I will consider this feature. This is typically my code of list comprehension. Then I will include this in big brackets. So first and foremost, you have some for block. Just to extract each and every feature, you have some for block. Then you have some if condition. It means you have some filter. Then whosoever feature will pass this filter, then I will only consider this feature, and I will say just insert this feature in your list. This is my code of list comprehension. So let's try to implement all these stuffs, of course, using list comprehension. So what I will say is, very first I have to iterate as, let's say, for column in df.columns. Let me very first cross check whether my data frame is df or not. Yeah, it is df. Then I have some if block. Then I will say if df of column dot data type, or you can say dot d type, equals to object. It means if that feature follows my categorical nature, then only I will consider that column. I have to just enclose this in parentheses, and let me just execute this line of code. Now you will end up having your all the features that follows categorical nature. Now I have to store this feature somewhere else. So what I will say is, let's say this is exactly my categorical. And let me just execute this line of code, and I'm going to say, let me just print whatever my categorical list is. So I will say, let me just print this line of code. Now you will see you have all these features that are exactly categorical in nature. Similarly, using similar lines of code, you can extract all the numerical features with some manipulation in your code. Now I will say I have to just change this condition. I will say if this feature doesn't belong to my object category. And if I will execute this line of code, these are all the features that follows my numerical nature. So I have to store it some, let's say, in list. So I will say, let's say this is exactly my, let's say, numerical. And let me just execute, and I'm just going to say, let me just print my numerical list and let me execute this line of code. These are all my numerical features and these all are my categorical features. Now you can easily perform whatever analysis you want. So let's say we have all these set of numerical features. So on all these numerical features, I can perform, hey, can you return me what is my correlation matrix? So in such case, what I will do is I will say df.correlation and let me just execute this line of code. So these are all my correlation values, and over here whatever feature we have, these are exactly numerical in nature. Now you will see from this correlation matrix, let me make it more user friendly. So what I will do is I can call, or I will call heatmap on top of this matrix. So I will say sns.heatmap and I have to just pass this matrix, or I have to just pass this data frame inside my heatmap. And let me just execute it and let me make it more user friendly. So I'm going to say plt.figure and let me assign my own figure size. So I will say fig size. Let's say this time my figure size is, let's say, 12,6. Let's say this is my window size on which I have to visualize my what exactly is my heat map. And just to showcase your correlation values, I can play with one of my parameter, which is exactly anode parameter. So I will say anode equals to true, and if I will execute this line of code, now just in a while you will end up having your heat map where you have all these correlation values. So this is basically my heat map of job market analysis of India. So let me assign this title as well. So I will say plt.title, it is title, and I will say it is nothing but my heat map of job market analysis of India. Let's say this is exactly my title, and whatever title you want to perform, it's all up to you. And I will just execute this line of code. Now from this correlation matrix, you can visualize between minimum pay and my average pay rate. We have probably close to 0.98 correlation. It means there is a 98% probability. If my minimum pay increases, my average pay rate also increases, because I have derived this average pay rate itself from this minimum pay as well as from my maximum pay. So let's try to extract some conclusions from minimum pay, of course, and from my minimum experience. You will see we have probably value close to 0.7. It means there is a 70% probability if my experience or minimum experience increases, my minimum pay also increases. This is a layman explanation of whatever correlation value I have find out from this correlation matrix. It means both these features are very highly correlated. Those are exactly my minimum pay and exactly my minimum experience. It means they are very highly positive correlate. So let's try to find out all the correlation values with respect to, let's say, minimum pay. So what I will say is I have to just pass this feature which is exactly minimum pay over here. So I will say my feature is all about this. Let me just execute. These are all the correlation values between minimum pay and, let's say, between maximum pay. We have around 0.93 correlation. It means there is a 93% probability if minimum pay increases, my maximum pay also increases. This is a very easiest explanation of this correlation coefficient. So that's all about this session, and if you guys have any queries, any doubts, feel free to ask us in the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session what we have basically done is we have found all the categorical features as well as numerical features, and we have basically performed our correlation analysis just on data, and we have come up with this conclusion here. Between minimum pay and, of course, my minimum experience, we have certainly very high correlation that directly indicates here there is a higher probability if my minimum experience increases, my minimum pay also increases. This is a very common insight that we have find from this correlation matrix. In a similar way, in this session what we can do is, hey, can you perform what is a company based analysis, or can you find out which company has more number of jobs? It means anyhow you need data as, you need one feature as, let's say, company, and another feature as number of jobs. Imagine this is my data. So let's say my company is, let's say, Oracle India, and let's say I have to find out, hey, what are the total number of jobs with respect to this Oracle India. Similarly, we have some, let's say, some institute, let's say IIT Madras, and let's say I have to find out the total number of jobs at IIT Madras at various education levels. Let's say this is my problem statement, and the second problem statement is all about, we have to automate all these stuffs. In a nutshell, we have to define some function. Let's say perform analysis. Imagine this is my function. Over there, I have to pass just some feature, just some data frame, and we have to write certain blocks of code over there. So once I will call this function, which is basically my per_analysis, and we will pass some feature, and we will end up having our visualization. That's the power of my automation. Again, before doing automation, you have to do all these things where you have to find such a qualitative data. So I will say data of, let's say, company. Very first we have to access that feature. So I will say I have to just press tab over there. Let me show you that. If I'm going to say, let's say, let me show you what my data frame. Yeah, my data frame is df. So let me very first create a copy of my df. So I will say, let's say data is equals to, let's say, df.copy. Let me just execute this line of code. And if I'm going to say data.columns, just to get all the column names in the form of list, you will see we have a feature as company. You can just press tab. This is my feature. This is exactly all the values at different observations inside my company feature. So on top of this, what I will do is, I will say, if I will call, let's say, value count, so I will say dot value underscore counts. And if I will execute, these are all the values that you will achieve over there. Now, just to convert these stats into some data frame, either you can call data frame on top of this, or you can call reset underscore index over there. So I will say dot reset underscore index. Let me execute. So this is my data frame. Now on top of this data frame, what I will do is I can rename the column names. So let me just store it in, let's say, comp. Let me execute and let me print my comp, and I will say comp dot, let's say, columns, whatever column name you want to assign. Let's say the very first is my company name or institute name, whatever you want to mention. The second is all about number of jobs. Let's say these are all my features. Let me just execute, and if I'm going to print my comp, you will see this is my data frame. Now you will see with respect to IIT Bombay, which is one of the top-notch institute of India, have maximum number of jobs. Then we have some confidential, then we have some NIT colleges, then we have Oracle India, then we have JP Morgan and various institutes in India. Now, just to showcase, let's say, top 10 companies, I will pass index as, let's say, 0 to 10. Let me execute. You will see these are my top 10 companies. So what I will do is, I will say, why not use some bar chart or pie chart? So I will say this is my company name. Let me say these are all my company name. So on top of this, what I will do is, on x-axis, I basically need my company name. On y-axis, I need my number of jobs with respect to that company. So what I will say is, on x-axis, very first I have to access basically my company. So I will say this is on my x-axis. Now on y-axis, I will say company of, let's say, number of company or number of jobs. I will say just axis 0 to 10. Let me execute this line of code. And this is your amazing bar chart. But again, you will see on x-axis, your data gets overlapped. Now just to fix this issue, what you can do is you can tilt your x-axis. So I will say plt.xsticks. Over there, I will say I have a very amazing parameter, which is exactly my rotation. So I will say rotation is all about, I will say just do it in a vertical fashion. Let me execute this line of code. Now just in a while, you will get your amazing bar plot. But unfortunately, you are getting an attribute error. Let me go through with this error. It says it doesn't have any property as rotation. And again, it's my bad. It is rotation. Let me fix it. And let me again execute. You will see these are all the values over here that we are typically getting. You will see these are the bar and these are all these things. So these are my top-notch institutes who have the maximum number of jobs. Again, you can also visualize this similar stuffs using pie chart as well. So what I will do is, I will say on top of this, I will just call, let's say, pie. So I will say dot pie. And over here, let me go through it with documentation. Let me go through with that. So very first we have to assign some X, and we have to assign some labels to that pie chart, and we have all these custom parameters. And what this function will do, it will plot a pie chart whatever data we will pass to it. So let me show you that. So this is exactly my company. So I will say this is exactly my labels, and I will say on x-axis I basically need my number of jobs. Or let me show you that. Let me show you that on X what I have to pass. Let me show you that. Yeah, I have to pass one dimensional array like, or the size that we have. So typically the size over here basically tends to the number of jobs that we have over here. And of course labels are all about my company names. Now what we have to do is we have to just execute this line of code, and you will get this amazing pie chart. You will see Confidential and IIT Bombay of course has domination over there. And just to make things more user friendly, what you can do is I will say this is exactly plt.figure over there. This is figure size, and I will say 12,6. And then I can, let's say, tilt my x-axis as well. So I will say basically my rotation is all about vertical. Let me just execute this line of code. Now over here you are getting this amazing pie chart where you can clearly see Confidential and IIT Bombay, and of course your NIT has amazing domination over there. They are covering almost more than 50% of your entire number of jobs in India. So let's try to automate all these stuff. So very first I have to define some function so that we will automate it. So I will say perform underscore analysis. So I will say, let's say perform underscore analysis, and we have to just pass some very first some data frame. Then I will say I have to pass some feature name. Then again let me show you that. Very first what we have done is we have very first call value counts on top of the feature that I have passed. So I'm going to say very first thing that I have done is all about whatever feature I have on top of this, I have just called my value counts, and I have achieved my data frame. Let's say my data frame is all about, let's say, data frame. So I will store it in, let's say, data frame. Now on top of this data frame, I will say I have to assign some column name. So I will say dot columns equals to column 1 and column 2. Now I have to receive the value of column 1 and column 2 of course from my function. So I will say why not receive its value from function. So once you will receive its value from function, now what I will do is, let's say you have to showcase either your pie chart, either your bar chart, depending upon the input that user have passed. Imagine the user have passed if input as 1, then I will say just showcase this bar chart. If the user has passed an input as 2, just showcase this pie chart. So I will say if chart equals to 1. In such case what I will do is I will say just to showcase your bar chart. So this is exactly my code of entire bar chart. So what I will do is I will say just paste all this code and just provide proper indentation. And of course my data frame was exactly my data frame. So I will say this is my exactly data frame, and of course my feature is all about whatever column 1 we have. So I will say it is all about my column 1, and we have to access of course top 10 value. And then I will say we have to pass all these stuffs over there, of course over there, and over there I will say I have to manipulate it. This is my column 2. I will say this is my column 2. Now we have to write some code for my pie chart as well. So I will say elif my chart equals to 2. It means I have to receive the value of chart from my function. So I will say, let's say chart, and let's set some by default value of chart, let's say as 1. So if my value of chart is, let's say 2, in such case I will execute my pie chart. So I will say this is exactly my pie, and these are all about whatever my labels we have on top of my pie chart, and this is exactly my data of my pie chart. So let me just execute this line of code, and I'm going to say perform analysis, and we have to just pass some set of features over there. Let's say my data frame is, let's say, data. Let's say my feature name is all about, let's say, company, and let's say the feature name that we have assigned over here, let's say these are the feature name that I have assigned to my company data frame. So what I will do is I will say why not assign the feature name as all these stuffs, And if I will execute this line of code, let me show you all these things. Now you will see after just executing this line of code, you will end up having your amazing pie chart. Imagine you need, let's say, pie charts. Why not just pass 2? And let me execute this line of code. This is your amazing pie chart. If you want to customize its figure size, you can just play with all these things over here. Just set your own figure size. That's not rocket science. So just imagine how optimal your code is. Just to find this similar visualization, you have written tons of code over there. Approx 3 lines of code just to visualize this, and 2-3 more lines of code just to end up having your final data. Again, just to reduce your code, defining a function is an extremely used way. So that's all about this session. In the upcoming session, we will try to understand data in much more depth. So if you guys have any issues, any error while going through with this course, feel free to drop your query in the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session, what we have done basically is we have automated our analysis by basically defining a function, and inside that function, we have written all the blocks of code that is exactly necessary just to come up with meaningful insight, whether in the form of bar chart or whether in the form of pie chart. That's what we have done typically in the previous session. We have our problem statement as, hey, can you make your code readable? Because in the real world, in context to real world, your readability matters a lot. Again, extensively used module like pandas, which is extensively used in data manipulation, data pre-processing. Of course, my NumPy, which is extremely used in numerical cases. For visualization, we have Seaborn. Even for the machine learning, we have scikit-learn, we have TensorFlow, we have lots of library. In all this library, we have lots of classes and lots of function. So to make all the functions, all the codes more readable, what we will do is we will use a concept often known as, either we can use something known as comment, we can comment the code, or if we have lots of parameters in a class, we can use a concept known as docstring, that is often known as document string in Python. So typically we use this docstring, of course, in Python. So what it will do is it will just provide a convenient way just to document your Python modules, functions, classes, and of course my methods. Let me show you all these stuff, let's say with respect to, let's say, read underscore CSV function, which is responsible for reading a CSV file. So let me show you that if I will say read underscore CSV, and over there if I will press shift plus tab, now you will see these typically, these all are my parameters. Look at this, these all are my parameters, and let me show you that, yeah. This is typically my docstring. So what it will do is it will just read a CSV file and it will convert it into a data frame data structure. That's what my read underscore CSV function will do for us. Over here you will see we have all these parameters. We have file path where we have to mention our file path. We have some separator, tons of parameters, and look at this, look at the documentation available over here. Again, the better the module will be, the better documentation you will get. So just to get its documentation, I will call its attribute, often known as underscore underscore. Let me press tab, and this is exactly doc underscore, yeah, sure, this one. And what I can do is I can say, why not just print its docstring, or why not just print its documentation? Let me just execute. Now this is exactly my all the documentation with respect to my read underscore CSV function, which is an inbuilt function defined in my pandas module. Now look at this. What it will do is it will just read a CSV file and convert it into data frame. And of course, these are all the things that also lies under my documentation. These are all the parameters of this function. Look at this file path, separator, and we have tons of parameters. Depending upon the use case, you can play with all these parameters. So in a similar way, you have to make your function as well, just to provide readability in your code. So I will say this function, what this function will do for us, this will return us plots depending upon whatever chart we want. So I will add my docstring using this tuple codes. You can add a docstring in Python just to provide readability using this tuple codes. So inside this tuple code, the first and foremost thing that we have to write is all about this will return us some plots depending upon whatever chart we want. So I will say whatever chart we want. This is exactly my docstring. And again, you can define some more thing like hey, what exactly this parameter stands for, what exactly this parameter stands for. These are all the things that you can define inside this docstring. So let's define some parameter as well. So I will say these are typically my all the parameters, and I will define over there. So over here I will say my very first parameter is exactly my data. So data is all about whatever data frame I will receive. Then I will say the second parameter is exactly my feature. In feature, I will say the column name that we have to consider for the analysis. So I will say column underscore name that we have to consider for analysis. Let's say this is all about my feature. So I will say this is exactly column name that we have to consider for my analysis. Similarly, we can say we have some more parameter as, hey, what does this column 1 stand for? So I will say this is exactly my first column name. This is exactly my first column name that you want to assign to your new data frame. So I will say that you want to assign, to new df or new data frame, whatever you want to mention. In a similar way, you can also mention your column 2 as well. So I will say column 2 is all about nothing but my second column, or I will say my second column name that you want to assign to your new data frame. This is all about my all these 4 parameters. Now let's talk about, hey, what does this chart means? So I will say, I will say chart if its value is 1. I will say if its value is 1, then it represent typically my bar chart. So I will say it represent my bar chart. But what if its value is 2? So I will say if its value is 2, then it will represent my pie chart. Then I will say it will represent my pie chart. So this is exactly my all about my docstring that will make my code more easier to understand, as well as it will provide readability to my code. Now let me show you one more thing. If I will execute it, let me show you one more thing. If I will call this function, which is exactly my perform underscore analysis, and over there if I will press, let's say, shift plus tab, now you can see the docstring. So what this function will do for us is this will return us plots depending upon whatever chart we want. Now below are all the parameters that my function receive. The first and foremost parameter, hey, what is your data? That is all about my data frame on which we are currently working. So you can manipulate all these parameters as well. That's not rocket science. Now we have some feature. Of course, this is typically my feature. Then my feature is all about the column name that we have to consider for the analysis. Now we have all the parameters over there. And if my value of the chart is 1, it represents bar chart. If it's 2, it represents pie chart. And this is all about the file where this function is available, and its type is function. This is all about your Python documentation string. So if I will say dot underscore, and you can just press tab over there to get all the attributes, or you can say to get all the inbuilt attributes available inside this function. I will say dot underscore doc. This will give me my documentation string. So why not just print it? So I will say why not just print it. And if I will execute this line of code, this will return us all these stats over there. Of course, these are nothing but my documentation. So that's all about this session. And if you guys still want to manipulate this docstring, you can just manipulate, let's say this is the data frame on which we are working. That's all up to you. That's not a big deal. So that's all about this session. And if you guys have any issues or any error, feel free to drop in the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session what we have done is we have just provided, of course, our documentation string or doc string to the function, to the custom function that we have written. So in this session what we have to do is we have to perform some lots of analysis just to come up with some meaningful insight. The first and foremost problem statement is all about, hey, can you perform the industry-based analysis? Or can you find out which industry has more number of jobs? It means you need your data as you need your one feature where you have a feature as industry. The second feature that you need is exactly number of jobs. Imagine my first industry, let's say IT industry. Imagine this is my first industry, and let's say we have number of jobs, let's say 50k. Imagine this is just an assumption. Similarly, let's say our second industry, let's say edtech or education industry. And let's say we have some count, let's say 40k. Imagine this is the count with respect to education. So we need typically data in such a format so that we can come up with this conclusion, hey, which industry has more number of jobs? In a nutshell, we have to come up with this data. So of course, just to do this, we have tons of ways. Again, we have already a function that we have defined, which is of course my perform_analysis. We will just call this custom function, just pass this feature, which is my industry feature, just assign this feature name to the new data frame, and we will say just pass a value, let's say chart equals to 1 or chart equals to 2, so that we will come up with bar chart or pie chart. This is what we will do just to come up with this meaningful insight for this problem statement. So let's try to implement all these stuffs in Python. So I'm going to say I have to just call this function over there. If I will press shift plus tab, this is all about the signature of this function. Look at this, and this is typically my syntax and the features. It is extremely straightforward. That's not rocket science. Again, we have to very first pass my data frame, which is exactly my data. Then we have to pass on what feature we have to perform this analysis. Then my feature is basically my industry. So I will say it is my exactly industry. Now the column name that we have to assign. So I will say the first column name that we have to assign to my new data frame is exactly my industries. The second is exactly my number of jobs. And let's say I need a pie chart. So in such case, I can pass 2. Why? Because you can check. If the value of chart is 2, it represents my pie chart. That's why we have to pass 2. And let me just execute this line of code. And just in a while, this is my amazing pie chart. Look at this. Now, of course, from this visualization, we can come up with this conclusion. Yeah, of course, my most number of the jobs are associated with my IT industry. Then we have jobs with respect to education. Then we have call center jobs, then we have internet jobs, then we have jobs in some banking domain, and lots of domain we have. Again, if you want to print some top 5 stats, what you can do is, once you get this data frame, I will say print something else. So I will say data frame dot head, let's say 4 or 5, whatever else you want to pass. Let me again execute this line of code, and let me just again execute this line of code. So these are typically my top 5. Of course, this is my first company or first institute where we have more number of jobs. This is my previous problem statement, and this is exactly this problem statement with respect to this session, where we have IT software industry and we have more number of jobs, where we have education teaching line and we have that much number of jobs. So this is typically my analysis where we have come up with this conclusion here. IT sector has the most number of jobs. It means it is that sector which is producing most number of jobs in India. Of course, it is one of the most growing sector in India. In a similar way, we have some more problem statement as, hey, can you find out what are my top performing job titles, or can you perform something known as job title analysis? So in such case, let me show you one more thing. If I'm going to say, let's say data dot columns, and if I will execute it, these are all the column names that you have. My feature is all about my job title. So let me just call this function, which is my perform_analysis. My first parameter is data. Of course, the second is my job title. Then I will say I have to assign some column names. So I will say the first is my, let's say job titles. Then we have number of jobs. Then I will say, I need, bar chart this time, or pie chart, whatever else you want. Let me just execute this line of code. And of course, these are my top 5 job titles where we have most number of the jobs. Again, you can see software engineer jobs in India are again close to 100. Of course, business jobs, of course, these are my top 5 jobs. And this is typically my pie chart representation of our problem statement. In a similar way, can you perform the skills analysis, or hey, can you showcase me the data where we have 2 features, where we have a skill and the number of jobs associated with that skills. It means we need such data just to come up with the conclusion. So I will just call this function, which is my perform_analysis. Over there, we have to just pass this data. The first feature is exactly my skills. Then I have to name my feature name, which is my, let's say, skills, and of course, let's say count, or let's say number of jobs, whatever else you want to mention. Then I will say, at this time I need, let's say, bar chart. Let me just execute this line of code, and these are my top 5 skills for which we have most number of the jobs. Now you will see, of course, IT is one of the most growing sector in India. You can see IT, sales and teaching, of course. These are my most growing sector in India. In a similar way, hey, can you perform the job location analysis? Or, hey, can you come up with a conclusion? What are the name of those cities which are producing most number of jobs? So in such case, I need data as, let's say I have some city, let's say I have some cities, and with respect to the cities, I need one more feature, let's say the number of jobs. Anyhow, I have to come up with this data. Imagine my city is, let's say, New Delhi, which is of course a capital of India. Imagine with respect to New Delhi, let's say we have 10k jobs. Similarly, with respect to Mumbai, which is of course the financial capital of India. Let's say with respect to Mumbai, we have, let's say, 15k jobs. Similarly, let's say with respect to Bengaluru, which is the IT hub of India, hey, can tell me what are the total number of jobs with respect to Bengaluru? Let's say 20k jobs. So in nutshell, we need such a data just to come up with this conclusion. What are my top cities that are producing the most number of the jobs? This is typically my high level overview. What we exactly need. Again, just to come up with this conclusion, you can just call this function. That's not a big deal. So very first we have to cross check what exactly is my feature name. So I will say data.columns, and you will see your feature is exactly job location underscore address. Now what I will do is I will just call a function which is my perform underscore analysis. My feature name, or very first we have to mention what is my data frame. Let me cross check all these things. Yeah. First and foremost, you have to mention what is your data. Then you can think for your feature name that you have to consider for the analysis, then column 1, column 2, and lots of features as well. So the second is your feature name, and this is my feature name. The third is, of course, the city name, and the fourth is, let's say job count. Let's say this time it is job count. And then I will say, let's say this time, let's say I need a pie chart. Let me just execute this line of code. Now you will see Bangalore is that city which is producing the most number of the jobs in India. Then we have this hierarchy, then we have Mumbai, then we have Delhi, then we have Hyderabad and Chennai. So these are typically my top 5 cities that are producing maximum number of the jobs in India. Again, you can perform data cleaning in much more depth just to manipulate this job count stats up to some extent. But typically most number of the jobs are with respect to Bengaluru, which is the IT hub of India. Then we have financial city, then we have, of course, a capital of India. So let's try to rename this notebook. So I will say this is nothing but my, let's say, 2 data analysis underscore Naukri underscore analysis underscore, of course, this is my part 1. So I will say this is all about my notebook name. You can rename it. That's okay. Now you can save it by just using Ctrl+S just to save all the code. So that's all about this session. In all our upcoming session, we will try to understand data in much more depth. So that's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in all our previous session, we have cleaned data, manipulated, defining custom function, automated, providing the docstring, and perform much more analysis. So in this session, what we have to do is, the first and foremost assignment is, hey, can you analyze the relationship between experience and period? So first and foremost, what we will do is, we will try to very first name this notebook or rename this notebook. Let's say this time it is all about, it is basically my third notebook. So I will say 3 data analysis underscore Naukri underscore analysis underscore part 2. Let me just rename it, and first and foremost, I will just import some of the modules that are very handy for us, of course, in upcoming session. So first and foremost, we will import pandas. Then I can think for NumPy, just for numerical stuff, and just for visualization, I can say matplotlib, and then I will say .python plot, and I will say let me first create its alias that says plt. Then I can also import my cbon, so I will say import cbon, and I will create its alias that says sns. Let me execute this line of code. Then using this pd, I have to just call an inbuilt function which is read underscore csv. Over there we have to just pass some file path and file name and all these things. That this is not a big deal. We have already written this line of code multiple times. So I will say this is my path. Let me very first append raw string, and I will say, let's say my data is all about, let's say Naukri underscore data.csv. So it will exactly return me some data frame. Let me store it in df. I will say df.head, and let me pass, let's say, some 2 just to showcase first 2 rows. Let me execute. These are my first 2 rows. Now the problem statement is, hey, can you analyze what is the relationship between experience and pay rate? So since both the features, let's say, which is my minimum pay, and let's say my another feature which is my, let's say, minimum experience, since both the feature are float in nature, because we have all the values which are float. So again, as both the features are numerical in nature, it is a case of bivariate analysis. So typically it is a case of bivariate analysis where my both the features are my numerical in nature. Again, if both the features are numerical in nature, you can think of using something known as regression plot, or you can also think of scatter plot. That will typically gives us, hey, what is the relationship between both the two features, because both the features are numerical in nature. So if, again, just to come up with this conclusion, either you can think of scatter plot or regression plot, or you can also think of something known as box plot, because over here my minimum experience have some bins. You will see my minimum experience can be 0, 1, 2, 3 and so on. So what I can do is I can say, let's say this is my visualization, and I will say on x-axis, let me very first erase all these things. So first and foremost, I will say, let's say this is my entire visualization. So I will say on x-axis, let's say I have, let's say, minimum experience, and on y-axis I will say, let's say I have minimum pay rate. Of course, pay rate cannot have bins, or pay rate cannot have minimum range, because it can vary up to greater extent. But of course, minimum experience can be in some range. Imagine 0, 1, 2, 3, 4, so on, let's say 10. So I will say, hey, can you return me what is the distribution when, or you can say, hey, can you return me what is the distribution of minimum pay rate when my minimum experience is 0? Can you obtain such kind of distribution? So just to come up with this problem statement, you can think of something known as box plot. So I will say, just plot a box plot of this. Imagine this is my box plot, and I have, let's say, some data points. These are exactly my outliers. Similarly, let's say when my minimum experience is 4, can you tell me what is the distribution of minimum pay rate when my minimum experience is 4? Imagine this is a box plot of this. This is my Q3, which is my 75th percentile data, or often known as upper quartile. This is my often known as Q1, which is my lower quartile. This is my minimum value, and this is my Q2, which is my median. This is my maximum value. So this is typically my distribution where my minimum experience is 4, and this is distribution of minimum pay rate where my minimum experience is 4. So hey, can you analyze what is the relationship between my minimum pay and my minimum experience? Imagine this is a problem statement. So just for this problem statement, you have, let's say, 3 ways. The first and foremost way, as both are numerical nature, you can think of scatter plot, or you can think of regression plot just to find a regression line. The third you can think of also is my box plot. These are typically my 3 ways just to analyze this problem statement. Again, to make your box plot more attractive, what you can do is, you can, let's say, hey, can you plot all the data points when my minimum experience is 0? So in such case, along with box plot, you can also think of something known as strip plot. So what this strip plot will do, it will plot all the data points when my experience or minimum experience is 0 and my minimum pay rate is available. Or can you plot the distribution of minimum pay rate where my minimum experience is 0, or can you plot all the data points? So in such case, you can think of using strip plot. So let's try to do this, all these things using Python. So very first I'm going to say SNS dot strip plot. Over there, if I will press Shift plus Tab, this is all about the signature and documentation, all these things. On x-axis, let's say I have to pass, let's say minimum experience. Let's say minimum underscore experience. Let me very first cross check all the column names. I will say data dot columns. Let me execute this line of code. Of course, data is not defined because we have df as your data frame. So what I will do is, first and foremost, what I will do is, I will say, let me just create a copy of data frame. So I will say data is equals to df.copy. Let me execute this line of code and let me again execute it. Now you will see, you will get all the column names. Now on y-axis, I can pass my minimum pay. So I will say on y-axis, I will just pass this minimum pay and I will just enclose it. And I will say inside this data, I have to pass my data. Let me execute this line of code. Now this is exactly, you can say, a distribution of all the data points where we have different minimum experience and minimum pay. Let me make this more results user friendly. So what I will do is, I will say plt.figure and I can just manipulate my figure size. That's it. So I will say, you can just press tab and you will see this is my fixed size. Fixed size is all about, let's say 14, let's say 8 or 6. Let me again execute it. And this time you will get this amazing strip plot. These are all the minimum experience, and on y-axis I have minimum pay. Now what I will do is, I will say on top of this strip plot, why not just map your box plot? So I will say sns.boxplot and I have all these parameters over there. So I will just paste it. Now in addition to that, you can add some title on top of your box plot. So I will say plt.title. Inside this title, I will say, let's say strip plots between, let's say strip plots between my minimum experience and my maximum experience. Let's say this is my title. So what I will do is, I will say just execute this blocks of code and just in a while you will get an amazing box plot along with your strip plot. Look at this distribution along with your box plot. Now from this visualization, you can say, when let's say with respect to, let's say minimum experience as 2, then I can say when we have a minimum experience as 2, there are very few jobs where we have a higher minimum pay. Of course, these are my outliers, often known as high outliers. That directly says we have very few number of jobs having a 2 years as minimum experience and we have a very high pay. But as soon as your minimum experience increases, you can see your average pay or your minimum pay also gets increases, because typically this is my median. This is my median. You can see your median constantly increases. It means as my minimum experience increases, your minimum pay also increases. That is typically your conclusion from this entire visualization. So let's try to visualize some more visualization over here. In a similar way, I can also consider the similar visualization for my maximum experience as well as for my maximum pay. So what I will do is, I will say this time, this is all about my maximum experience. This is all about my maximum pay. Similarly, this is all about my maximum experience and this is all about my maximum pay. That's it. Let's try to manipulate your title and let's try to manipulate your, this is my maximum pay. I will say this is my maximum pay. And let me just execute these blocks of code. And just in a while, you will end up having your final visualization. Now, of course, from this final visualization, we can come up with this conclusion. Yeah, of course. When we have a, let's say, maximum experience as 4, there are very few number of jobs where we have approx higher maximum pay. And of course, as soon as your maximum experience increases, there is a very high probability that your maximum pay also increases in most of the cases. Not in every case, because you can see we have some uneven distribution over there. Similarly, if we have a maximum experience as 21, look at this distribution. This is far high from all the distribution that we have. But in general, as soon as my maximum experience increases, there is a very high probability that we will get our continuous increasing curve. Of course, not increasing in a continuous manner, but of course, up to some extent it increases. So that's all about this session. And if you guys have any issues, any doubts in this session and in this entire use case, please feel free to drop your query in the Q&A of the course. We will try to respond as soon as possible and we will try to provide necessary solution to you. So that's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. In the last session, since we have found out the relationship between our experience feature and our pay rate feature, so let's go slightly ahead and understand the next big idea, which is all about, hey, can you find out what exactly is the median of the maximum pay in different industry? Again, this is the problem statement that you have to solve. It means you need data as, you need one feature, let's say as industry, and you need another feature, let's say as median underscore max pay. Let's say this is my second feature name, and let's say my industry, let's say the very first industry, let's say as finance, and let's say IT, let's say accounting. Let's say these are my most frequent industry. Imagine we have some median. Let's say let's say 10K, let's say 20K, let's say 40K. Imagine this is the median of the maximum pay with respect to different industries. So in a nutshell, we have to come up with such data so that I can showcase it using bar chart or using pie chart. So very first I will say I just need two features. First feature is exactly maximum underscore pay. The second feature is exactly my all about industry. If I will execute, these are my two features. Now on top of this data frame that I have achieved, I will say just group your data frame considering your industry feature, this industry feature. So I will say on top of this, I will just call a group by. Over there, I will say just group it considering this feature. Now once I will group my data on top of this, if I will say just call, let's say median, and if I will execute, this is typically my median of a maximum pay in all these industries. Again, this is your very first approach where you can use your group by functionality and you can come up with this table. The second approach you can think of is group by along with some aggregation function. Let's say mean, median, maximum, minimum, count. These are all about my aggregation that you can perform on top of each and every feature in your data frame. These are typically my aggregation. So of course, this is your practice problem that we will discuss at the end of this use case. Again, there are some more other ways, but these are my most frequent used ways just to come up with this such type of data. Now I will say, why not just short this data frame? So I will say dot short underscore values over there. If I will press shift plus tab, over here we have a very important parameter which is exactly by. It means on what column basis you have to short this data frame. And over here, if I will execute it, now you will see these are those industries which have least maximum pay, or it means these are those industries. Typically the first 5 are those industries which have my least median pay. So what I will say is, I can assign my ascending equals to false because by default this ascending equals to true. Let me execute it, and now of course these are my top of 5 industries. Now on top of this I will say, why not just call head of 10. Let me just execute it. These are my top 10 industries. And if you want to visualize it, what I will do is I will say just call, let's say plot, and over here we have a very handy parameter which is exactly kind. Over there I can say I just need my bar chart. Let me execute this line of code, and just in a couple of seconds you get this amazing visualization. And if you want to play with your color parameter, I will say color is all about, let's say green chart. So I will say that's it. Let me execute, and this is your amazing green chart. Now you will see with respect to pulp and paper, you have your maximum pay, or you can say you have your maximum median pay. These are my top 10 industries that have maximum median pay. In a similar way, I can also come up with some more conclusion using the similar block of code. And after doing just some basic manipulation, I will say, hey, can you find with respect to, let's say, minimum pay? And if I will execute this line of code, now you are getting a key error. Now let's try to understand what this error is all about. It says, hey, you have a key error as minimum pay. It means there is no such key available as minimum pay in your data frame, because we have extracted just 2 features from my data. So I will say my feature name that we have to extract itself from this data is exactly minimum pay. And if I will execute again, now you will see these are my top 10 industries which have highest median minimum pay. These are my top 10 industries. So our next problem statement is all about, hey, can you come up with this conclusion which is my top rated skill? It means we have to find out that skill which have a maximum pay. In nutshell, this is a core idea. So what I can do is I can say, of course, there are tons of ways to do this. We can use some visualization approach. Just to come up with this conclusion. You can also use some tabular approaches where you can think of some data in the form of data frame. Let's say you can call, group Y on top of your skill feature, and you can say, hey, just call median of your average pay rate, and that's it. This is your tabular approach. In visualization approach, I can say, why not just create a visualization, let's say box plot. So on x-axis, let's say I have all the skills, and let's say on y-axis I have, let's say, average pay. Let's say this is my typical scenario. So what I can do is, let's say my skill is, let's say, IT. Imagine, let's say programming. Or let's say my skill is, let's say, machine learning, or let's say data analysis. Imagine, just assume this scenario. So what I can do is I can say, hey, can you return me a distribution of average pay where my skill is, let's say, machine learning. Imagine this is my, box plot. Imagine this is a box plot for, let's say, data analysis skill. Similarly, can you return me what is a box plot of, let's say, programming? Imagine this is a box plot. So in nutshell, the core idea is, if I can come up with such visualization, then I can easily say, hey, of course, I can come up with the conclusion which is my top rated skill, because bigger this box will be, there is a higher probability that that skill is one of the top rated skill. This is the core idea behind this my box plot. So what I will do is, I will just call, let's say, box plot. So I will say SNS dot box plot. On x-axis, I just need my skills. So I will say on x-axis, I need my skills. On y-axis, I typically need my average pay rate. So I will say, I just need my, on y-axis, I will say, this is exactly my y-axis average underscore pay rate. So I will say average underscore pay rate. Of course, let me cross check all these things. So if I will say data dot columns to cross check all the column names. This is exactly my dot underscore columns. Let me execute it. Yeah. You will see we have a feature as skills, and we have a feature, of course, as average underscore pay rate. Now, sounds good. Now what we have to do is, we will say, of course, my data frame is all about my data, and let me customize my figure size. So I will say this time my plt dot figure, my parameter is all about fig size. So I will say it is all about, let's say, 12,8. Or to make your visualization more bigger, you can think of 20,10. Let me just execute this line of code. Now you will see this is your, of course, you can see on x-axis your skills are getting overlapped. So what you can do is, I can say plt dot xsticks. Over there I can set my rotation parameter, of course, as vertical. So I will say rotation is all about, let's say, vertical. Let me just again execute this line of code, and I will say this is my amazing box plot. Now you will see with respect to each of the skill, you have some different kind of box plot. So let me very first compute, or let me very first calculate what are the total number of different skills you have. So I will say data of course, my skills dot and unique. And if I will execute, you will see we have total unique skills as 45. It means the box plot that you will observe is with respect to 45 skills that you have inside your data. Now from this box plot, I can say the first and foremost thing is you have your top management skill. Then you have your IT software skill. Then we have all other skills as well. Then we have this network administration skill and some more other skill as well. So let's say, hey, can you find what are my top 10 skills for which I have a decent pay? Can you just find out all these things? So I will say data dot group by. We have to create a groups considering my skills feature. Now once I will create a groups of skills, then I will say on top of my average underscore pay rate feature, I will say just call, let's say, median function. So I will say underscore pay rate. On top of this, I will just call, let's say, median. And if I will execute this line of code, this is your amazing stats over there. Now on top of this, I will say just call short underscore values. And over there, I have to just say, let's say, again, before calling this short underscore values, we have to make sure that the data that you have must be in the form of data frame data structure. But unfortunately, this is that data that you have in the form of series data structure. So first and foremost, what you can do is you can say dot reset underscore index. On top of this, if I will execute it, this is my data that we have. Now over there, if I will say dot short underscore values, I will say as by is equals to all about average underscore pay rate, and I have one more parameter which is exactly my ascending parameter. So I will say just assign false, and this is typically my all the stats. You will see one of my top rated skill is my top management. Then we have IT skill. Then we have shipping, packaging, IT software, and all these things. Or again, these are typically my those skills that are exactly in my hierarchy. Or can you find out the top 10 skill? So for this, what I will do is I will say dot head of 10. Let me again execute. These are my top 10 skills. Again, just to plot it, you can just call a bar chart. So I will say first and foremost, I have to make this skills as your index. So what I will do is I will say set underscore index. Over there, I will say just make it as my index, and if I will execute it, this is now my index. On top of this, I will say dot plot, and over there I have a parameter which is my kind equals to bar. That's it. Just execute this line of code, and this is your amazing bar plot. Over there, these are my top 10 skills for which I can get a premium amount. So that's all about this session. In the upcoming session, we will try to analyze, hey, can you analyze the available positions in the industry? So this is typically my industry feature that we have to consider for the upcoming session. So that's all about this session. And if you guys have any issues, any queries in this session, feel free to drop your query in the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, since we have understood our data pretty well, let's go slightly ahead and understand the next big idea, which is all about some more problem statement. So in this session, our cool challenge is all about, hey, can you analyze the available position in the industries? Again, we have lots of industry and we have to explore it. So if I will say data of number of position, very first and foremost, we have to access a feature which is exactly number of positions. You can just press tab over here so that you will get the entire feature. So what I will do is on top of this, if I will call this number of unique values, and if I will execute this line of code, it will say you have that much total number of unique positions inside this data frame. That's what this function will do for us. So now what we have to do is, if I will say data dot, let's say head, and let me just pass some value, let's say 3. So you will see we have a feature which is exactly number of the positions that we have. So just to analyze the problem statement that we have, hey, can you analyze the available position in the industry? It means we need data as the first thing that I need is exactly my industry. And the second thing that I need, the total number of the positions. This is what I need. Imagine I have an industry, let's say it's finance. So I have to come up with this conclusion. The total number of the unique positions with respect to my finance industry. Imagine it is 3K. Similarly, let's say our industry is, let's say, architecture or let's say IT. So typically, I just need such kind of data, and if I can have such kind of data, I am done. Again, just to come up with such data, what I will do is, I will say, just call a group by considering this industry feature. So I will say, just call a group by on top of this feature. So once we have a group by, then I will say, on top of our number of positions feature, just call a sum function. And if I am able to write this line of code using Python, I can end up having such data. That's it. Again, this line of code typically returns data in the form of series data structure. Again, just to get the data in the form of data frame or in the panel, that's not a rocket science. You have to just call to_frame and you are done. You are just getting data in the form of data frame. You are done. But again, as this use case, as this problem statement is not complex, we can solve it using series data structure. So what I will do is, I can just write such line of code and I will end up having such kind of data. I can plot it. Either I can use pie chart, or either I can use bar, or either I can use donut. Tons of ways just to visualize this data. That's it. So I'm going to say data dot group by. First and foremost, I have to call this group by, and I will say I have to group my data considering this industry feature. Of course, we have to make sure that of course we must not have any case sensitive issues. So once we have this group by, I will say on top of this, we have to access our feature, which is exactly number of positions. On top of this, I will say just call a sum inbuilt function. That's it. And if I will execute this line of code, this is the data that we are getting. Again, this is the data exactly in the form of series data structure. Again, just to cross check it, you can just call type. That's it. And if I will call type, you will see it belongs to, of course, my series class. And again, this is a class that is defined itself in my pandas module. So if I will say, let me just paste this code and let me just execute. This is typically my all the stats that you have over here. So on top of these stats, I will say first and foremost, I have to sort the data. So I will say sort underscore values, considering what? Considering in a descending order. So I will say ascending equals to false, because by default this ascending is true. So I will say this is exactly my ascending. Once I will do all these things, now what I will do is I will say dot head and I will say, let's say 5. Let me just execute. These are typically my first 5 industry that have the maximum number of the positions that you have. So on top of this, what I will do is, let's say I will pass, let's say 10, and let me just execute this line of code. These are the top 10 industries. Again, call centers and medical has the highest number of the jobs in India, or the number of the positions in India. So on top of this, I will say just plot it. So I will say dot plot. Let's say I can use, let's say, pie chart. So I will say kind equals to pi. And let me just execute this line of code. Let's say you are getting such a visualization. Let's say I have to customize this pie chart. So what I will do is I can use one more very handy parameter, which is exactly autopcity, just to convert all the values in the form of percentage, or inside this pie, I can showcase its share. So what I will do is autopcity is all about, here I have to mention my data in the form of percentage. So what I will do is I will say percentage, of course, 1.1, and over here I have to use this f. Again, this is typically a notation just to obtain the values in the form of percentage. Now, if I will execute this line of code, these are all the values on top of your pie chart. Let me make it more user friendly. So what I will do is I will say, hey, can you assign some titles? So I will say plt.title. Over there, I can assign, let's say, pie chart. So I will say this is exactly my pie chart, and I can assign some font size. So I will say font size is all about, let's say 22. Once I will do this, I will say plt.show. First and foremost, I have to increase its window size. So what I will do is I will say plt.figure. Over there, I have a very handy parameter that is all about my figure size. This is exactly my figure size. I will say, let's say figure size is all about 14,8. Let me just execute this line of code. Again, now you are getting an attribute error. So let's try to tackle this error. It says the text object doesn't have any property as font, this one. Again, that's my bad, just because of the typo that I have done over here. Again, in the real world, you can get such typo and you have to deal with that. Again, always try to understand whatever the error, whatever the warning that you are getting, and you are done. Now let me just again execute this line of code. And of course, this is the amazing pie chart that we are getting. Now you can see BPO has the most number of the jobs. Then we have the medical, healthcare jobs. And then we have some IT jobs in India. Then we have some travel, hotels, restaurants, airlines. Then we have some pharma jobs. Then we have some clinical jobs. Then we have some advertising jobs. There are lots of jobs in India. So that's all about this session. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.